And we're off and running. Yeah, today, I mean, it's Thursday. We've been learning JavaScript for the past couple weeks. Next week, we're really going to dive in and start doing some behind the scenes stuff. So, starting to write JavaScript on the back end so that we can process data and interact with it. Eventually learn when we learn databases, we'll learn to store it in a server and then fetch those records. But what I wanted to focus on today is just continue to provide implementations of things that we would want to build from the front end. We're going to take a look at Andrew's example of like calculating the distance between 2 points. That's a really useful one. Another one I thought might be fun is learning how to make drag and drop elements so that we can drag things around the screen. That's another pretty common use of JavaScript, especially on the front end. But we're going to have tons of time today really just to review and go over anything we want to do in more detail, right? We can maybe build some projects together or continue to work on some of the ones that we've been playing with in the past. Okay, any questions or thoughts before we dive in? No? All right, the first thing we're going to do is we're going to work on the implementation of a lightweight distance calculation system. Okay, there's a bunch of functionality that JavaScript provides to us that lets us, it's not as useful in the context of a computer, but in a mobile app when you're walking around, right? The mobile app itself has a bunch of cool hardware in there, like a GPS system so that we know where we are at any given time, and we can use JavaScript to write code to let us take advantage of that information. And that includes things like accelerometers. We can tell if we're tilting the phone. We can tell if we could build a level, right, and use our phone as a level. There's a whole bunch of cool stuff we can do in JavaScript that really is exciting in the context of mobile devices, and we'll play with that today and see if we can make something useful here in our systems. All right, so I'm going to start a new project. So let's open up a new folder, and I'm going to call this folder, GPS. All right. Just like with anything else, we're going to start a new project. I'm probably going to make a JavaScript folder. I'm going to make a CSS folder. Oop, I don't want it to be under here. Good. New folder CSS. All right, and then I'm going to make an index.html file. Okay. And just like always, I'm going to use our little pre-built template, and we'll say GPS example. Okay. Great. So if we run this live server, we should see a blank page that has nothing on it of use. Okay, which is exactly where we're at. Let's come in here and say the first thing we probably need to evaluate here is how do we get our latitude and longitude currently? Like that's the first step. We need to know where we are in the world, and it's extremely easy to do this in JavaScript. So let's just give ourselves a heading: current GPS coordinates, h1. Okay, and we'll put in here and say div, and we'll give ourselves some information here. So we'll say right. We'll give ourselves a paragraph, and we'll say latitude, and we'll give ourselves an element, span ID equals lat. We'll put nothing in there. Let's put a 0 to begin with because it lets us know that we're working in the right spot. And then we'll just give ourselves a line break and then put in longitude. Right? Span ID equals long. 0, span. All right. So right now we're exactly where we think we should be. We've got a page, it's unstyled, and I think that's perfectly fine for this example. But we want to figure out what our current latitude and longitude is. So there is a special JavaScript object that exists in the browser. We've learned about a few of them. Window is one of those. Document is one of those. And then there's an object called Navigator. And this is actually a throwback to the olden days when Netscape Navigator was first built. That was a browser from the 90s. They were the ones that invented JavaScript in the first place. So they had a top-level Navigator object. Now, all of the browsers have implemented this object as well because a lot of useful functionality, specifically about the hardware or about the computer, come out of this object. So let's just take a look. So you can see we've got, behind the scenes, even though this is Google Chrome, our browser is identifying itself as, Mozilla or Netscape, right? And this is the actual browser string that we're sending when we make requests to the servers. Other interesting things in here, you can see we've got a Bluetooth object that does something. We have a clipboard object that does something where, when we copy and paste, that's probably what we would use that for. We can see information about our network connection, and it tells us things like, what is our effective speed connected to the internet. We can tell if we've got cookies enabled or not. We've got a do not track in here. So there's a whole bunch of useful features in this object that we're going to take advantage of. But the one that we need right now is the geolocation object, okay? And so the geolocation object taps into the computer's, on a phone, it's going to actually tap into like the geolocation, the GPS chip that you may or may not have. But on the browser, it does a bunch of special things. It talks to your internet service provider to try and get like where is this person actually located. And so, when we start playing with this here, right? I don't actually know what my geolocation object is going to return, but in theory, it should tell us something interesting that we can work with. Okay. So let's just take a look and see what it does. So we're in the console. Right? Let's just take a look, right? So we say navigator.geolocation, right? And this is the object itself. It has a prototype, right? So we know that a prototype is going to tell us the information of like the functions that exist on this object. So we've got a get current position that seems like it's probably what we want, and then like a watch position and a clear watch, which I imagine is like if we wanted to have this, if we're on a device that's moving around, those two functions are probably going to watch us as we're moving, which is interesting. But I think get current position is probably the thing that is really the only thing we probably need to use, because we can always call get current position whenever we want if we were on a device moving around. So let's just try this out and see what it does. Navigator.get geolocation.get current position, and this is a function. Let's see what it takes. Right, so it says one argument required and 0 is present. So let's just see. Let's put a variable in here. See what. Right, let's put in test as a string. Failed to execute get current position on geolocation. Parameter 1 is not of type function. So without even having to go look up documentation, we've put some information in here, and it's told us, A, it requires a argument, and we didn't pass anything. And when we passed something in, it told us parameter 1 is supposed to be type function. Okay. Now we could easily go and search on the internet. We could search Google and say, how do I get my coordinates in JavaScript? And it's going to show you like the 4 lines of code we need to write. But I wanted to investigate this from a perspective of like, I don't know anything, and we're going to play with it until we make it work. Like, this is a useful skill because there's no right or wrong way to learn and to experiment and to enjoy being a developer. This is one of those methods that I use pretty frequently when I'm just curious, right? So let's try putting in a function and see what happens. So let's do navigator.geolocation.get current position, and we're going to put in a function that is anonymous, and I don't know what arguments it's going to send to this function, so let's just do console.log arguments, right? We know that arguments is a magic object that the function will have. It's going to tell us whatever is passed to us. So I think this will probably give us everything we need to know about how to use this function. Okay, interesting. It popped up a little box that says this IP address wants to know your current location. So there's some browser security setting behind here that we have to authorize this. If we put no here, it would block it, and we'd have to turn that on later. Let's just click allow and see what happens. Okay, cool. So we get our arguments, like this function executed now. We got our arguments. We can see that it has, it's sending one thing, right? It's got a length of 1, and it's got a coordinates. Cool, and it gives us a latitude, a longitude. It gives us a heading. I don't know what that is. Maybe that's like if we had a compass, that might be something in here. And then if we had an altitude, like that would be our height if we're on a mountain. That's interesting. And then an accuracy. I don't know what this 20 means, but maybe it's accurate to within 20 meters, 20 feet. I don't know. We can play with that and see what happens. And then a timestamp. Maybe this timestamp is different all the time. We also apparently have a couple of functions that are available in this prototype, so we could like get the accurate. Okay, so they're using like the class mechanism, right? So these are getters, and in theory, we don't see any setters in here, so we can't overwrite this. This is telling us that this class or this object lets us get information, but does not let us set information, which makes sense. Like, we can't lie to the computer and tell us where we're at. So let's just grab this latitude and longitude, maybe punch it into Google Maps and see what it thinks where it thinks we're at. So let's say like Google Maps location by lat long. Let's all right. We can in the search box, type your coordinates. All right, so that seems pretty easy. We'll go to maps.google.com, and we'll type in latitude first. We'll say boop, and then comma. All right, negative 82. Right? And let's click search and see where that takes us. Hey, that's pretty close, right? So whatever this mechanism is doing is probably tied into our internet service provider so that it knows, hey, I'm here, right? That's neat, right? Cool. So that seems to be exactly what we want, right? We've got a navigator.geolocation object, and it gives us a get current position function, and that function takes a function and is going to give us some object with coordinates, right? So we can rewrite this like navigator.get geolocation.get current position function, and we'll just say maybe like chords or something, right? And we can do console.log chords. Okay, and we get a geolocation position object that has coordinates in it, right? That's its main thing. So well, let's try and tap into that so that when we load this page, we're going to get this information, and it will display in this, the lat and long spans. All right, so let's make ourselves a gps.js. All right, and we want this to happen when the page loads, so let's put this there. We'll say document.get element, or let's do document.add event listener. What event do we want to tap into here?
Geolocation.
No. We want this function to fire when the page loads.
DOM content loaded.
Exactly right, Estrella. DOM content loaded. Right, perfect. And inside this function, let's just try and grab that information, right? We'll say like var, or let's use let chords is a blank thing, right? We want this to be here. Let's make this global, right? Let's say, right, we're creating a chords variable in the object, and let's go navigator.geolocation.get current position, and it takes a function. So we'll say, geo, right? And then when it gets this information, we want to just store it in our coordinates, right? So we'll add some comments in here so we know what we're doing. When we load the page, get the coordinates and store it in an object, right? And then also we probably want to display the lat long in our lat long spans. Okay, so that seems reasonable, right? We know that this geo object has the chords in it, right? And if we ran this again, right, we know that it's an object that has a key of coordinates, and that has a latitude and longitude property. So let's first save it. Let's say chords equals geo chords. Okay, simple as that. And then let's do document.get element by ID lat dot inner HTML equals chords dot latitude. Neat. And then we do the same thing for longitude. Get element by ID longitude dot inner HTML equals chords dot longitude. Okay, so when we run this now, we should see okay, nothing happened. Interesting. Let's log this to see what's going on here. Console.log current position running. Okay, and reload the page. Nothing is happening. Interesting. Oh, I know why. We have not loaded our JavaScript. Right? A simple mistake to make. Script source equals JS gps.js. Okay, so because we did not include our script and it wasn't in our template, the JavaScript is never running. Right? So now we see current position running, and yes, indeed, latitude and longitude show up here. Right? So that's pretty cool. Now, in Andrew's specific example, we wanted to figure out how to compare the calculate the distance between 2 points, right? So if he's on a golf course and he walks, 50 yards up because that's where his ball was shot, if he calls get current position again, it's going to be some distance between these two things, right? And there's a really good algorithm for this, and we'll look at that algorithm here in a second and try to recreate it in JavaScript. But let's now that we know how to get our current position, let's maybe start thinking about like let's take this and let's figure out if we can make some distance stuff, right? So we'll say right, so span, and we'll call this current. Let's say h2 current position, right? Okay, so this is our current position. Let's copy this information into a second div that will be right next to it. Or, yeah, perfect. And I'm just gonna, for the sake of making all this line up, let's just say by float left, right, and then border 1px solid, 0, 0, 0. Right, we're gonna give it a black border. Yep. And we'll float this one left as well, so these will all be kind of compressed against each other. Okay, perfect. And we'll add let's add a margin left 10px. Right? So we could have used Flexbox for this, but just for the sake of doing this quickly, so we just kind of want to show stuff off, and let's add a padding. Go ahead.
Question: is there a way or a code way that you could like say how do you get the website to pick up the like say I'm using this website on my mobile devices? How would I code to allow or ask permission to allow you the GPS system on a device to post the current position?
I don't quite understand what you're saying. So if you're on a mobile device, how do we know that you're on a mobile device?
No, how would I code so that it would so when you go on this website on the mobile device, it will ask for permission to get information from the mobile device GPS system and post it onto the website. How you said post current position and yeah.
So get current position is going to work regardless of what device you're on. So
Okay.
if you're on a mobile device, or if you're on a computer, this still works as you can see. So I would just write the code to assume that it's going to be used on a mobile device. Like Andrew, if he's building a golf shot tracker app, he's not going to use it on his desktop because he's going to be using it on a golf course. He has to be on mobile. If he used it on his desktop, he would click, I'm currently here, and it's going to give him the same coordinates every time. It wouldn't be very useful for him to do so. Now, we can, using this navigator object, we can actually check information about, what type of device we're on. So here, platform, this says Win32. If you're on an Android phone or something like that, it's going to have a different value in here, and you'd have to look up what all those different values are. iPhone probably says iOS 9 or something, right? So we can use this same navigator object to tell us about what type of computer we're on if we wanted to code things differently. Does that answer your question?
Some ways, yes.
So what I'm doing here is I made a previous position, right? Let's just copy in these values, latitude here, right? Longitude here, and we'll just change these a little bit and see if we can calculate the distance between 2 points, right? So we know that currently I'm at this location, right? So if I wanted to use JavaScript to calculate the 2 points, right? So in Andrew's golf example, he's probably going to start from the tee box, at some fixed location, hit the ball, walk or drive a golf cart. This is the fun way. Drive a golf cart to his golf ball and get a different value. And so let's just change the value a tiny little bit, knowing that this is where I'm currently at. Let's say, this is 2, and maybe this is like 0.3, 0.3, right? So I don't know what each of these decimals in latitude and longitude represent some little slice or segment of the Earth in distance. When you're actually down in these small numbers where you're walking feet or inches or miles, right? Like the resolution here, people that are super good at maps might have this all memorized. But in general, I just want to be able to calculate the distance between the two of them, right? So we've got a latitude and longitude. We have an old lat, old long. Okay, and so let's just grab that and see what we get, right? So we can go, right, let old lat equals document dot get element by ID old lat, and we'll do the same thing for old long. Okay, did I name it correctly? Old lat, old long, yes, we're good. Old, long, awesome. So in theory, when this page loads, we probably want to make these global, right? So we want to make them exist outside of this function. So let's just define this up here as well. Let old lat, let old long. Okay. So now if we check these to make sure that we've got a value in here, old lat. What? Oh, I got the element. Dot inner text. Let's just grab the text out of here. Dot inner text. Okay, so now the old lat value has 3350 whatever, and then old long is going to have this as well. Now I know we're going to have to do math on this. So this is currently a string because we got the inner text. It was text that was just on the page. So let's, when we run navigator dot geolocation dot get current position, and we put in a function with chords in here, console.log coordinates chords dot latitude, right? These are chords latitude. Interesting. Console.log chords dot longitude. Maybe it's because we've already grabbed it once. Anyway, the point is, if we were to go in and look at the chords object that we stored, right? Chords dot latitude is a number. We're going to have to do math here to figure out the distance between these 2 points. So let's come at this from like a completely, like your boss is giving you a task. You're going to build this next latest and greatest golf shot app tracker, and you want to like calculate the distance between each hole. So if I did not know the name of this algorithm, I would maybe, my first reaction would be like, let's go to Google and say like, calculate distance between 2 points JavaScript, right? That's like a reasonable search for us to run. That's 2 points in the canvas, so maybe we want to say 2 locations JavaScript. Okay, great. This top result looks interesting. Oh, and it even tells us the name of the formula, right? So this person has used a website called Stack Overflow, which we've maybe seen a few times in our code. Stack Overflow is a great resource. It is a question and answer site by programmers for programmers so that we can help each other with programming problems. So this person says, I'm currently using the function below, and it doesn't work properly. According to Google Maps, the distance between these coordinates from whatever to whatever is 2.2 kilometers, while the function returns 1.6 kilometers. How can I make this return the correct distance? Okay? Interesting. And so what it's showing here is the correct answer is you're using the Haversine formula. So the code he's putting up here is Haversine, right? We don't even have to, and it's showing us that like the straight line distance between these 2 points is 1.6 kilometers, and Google Maps is telling you like the road distance, right? So right here in this very first Google search, we're getting the formula that we probably need, right? We put in a latitude 1, a longitude 1, latitude 2, and a longitude 2, and that's going to give us the distance in kilometers, right? So it's got a, we can see here that it's a function, get distance from lat long in kilometers. That's a pretty good name for a function. And then it's got another function called degrees to radians, and it's really just returning degrees times math.pi divided by 180. So that must be the formula for turning a degree into a radian. Now it's been 20 years since I had to do any kind of like math class or anything like that, but I assume that that is correct. Let's maybe look at what this function is doing, right? So we're defining a variable named r, and we're saying 6371, and he's got a comment here that says this is the radius of the Earth in kilometers. Okay, that's pretty cool. Then he's saying that the degree of the latitude is, he's calling this function degree to radian, of latitude 2 minus latitude 1, and then the degree of the longitude is same function, the longitude 2 minus longitude 1. All right, so he's getting d long, d lat. Then he's saying a whatever that's a poorly named variable. We should pick a better name for sure. Is math.sine that dlat divided by 2 times math.sine dlat divided by 2. So he's getting the square of dlat divided by 2. So this is like that times that is getting the square of this, plus the cosine of the degrees times math.cosine degree to radian. All right, that's interesting. And then he's saying c is 2 times math, the atan 2, right? So this is another object on the math object. We've been playing with these. Is the square root of a, which is this, and the square root of 1 minus a. And then the distance is r, so the distance of the radius of the Earth in kilometers, times c, which is this value. So let's maybe just copy this code and maybe walk through it and see what it's doing. Okay, this is a perfectly acceptable way to do software engineering. We're not going to use his code exactly. We're probably going to want to rewrite it ourselves, right? But it's here. It's a public resource, and I would be willing to bet if now that we know that this is called the Haber-Sign formula, we could actually go and learn what it's doing in Wikipedia, right? We can do a little bit of research, right? If you've been giving a task to program, if Andrew comes down and says, Estrella, I need you to program in this distance calculator, you're going to have more than 4 hours to work on this task, most likely, right? It's going to be something that he expects this to be a couple of days project for us. So we got a little bit of time to do some research. If you remember a couple of weeks ago when Mike was talking to you on as a guest speaker, he was saying, your job as software engineers is not to code, it's to research and think critically and figure out how to use code to solve problems, right? The problem is I want to be able to calculate the distance between the tee box and where our ball landed. We're going to do a tiny bit of research to find out that we need to use a crazy formula called Haber-Sign that gives us the great circle distance between 2 points on a sphere, right? So any of you that have taken higher level geometry probably already have experience with this type of formula, but I skipped all that because I was more interested in playing guitar and stuff like that. So we maybe would spend a little bit of time reading through this and understanding what it's actually doing if we cared, or if we know, hey, I just need to use Haber-Sign here, then if you've got a Haber-Sign implementation, we're just going to write this in our own words, right? Like, this is math. There's nothing, it's copyrighted in the sense that we didn't write this code, so we're going to rewrite this in our own words so that there's no possibility of copyright infringement. But the math itself is a public formula that was published, probably 1805, right? Some guy invented this in 1805. Cool. So if you were interested, right, it's kind of showing you what it's doing, right? It's making, some kind of triangle on a sphere, right? And obviously the triangle on the sphere is going to have weird bubbles. And so this algorithm is letting us calculate the distance between those 2 points. Cool. All right, so let's copy this code and see if we can start fiddling with it to see what it's doing. So maybe what we do as our next step is I'm going to come in here and let's just paste all this in, right? Get distance from lat long in kilometers. And I'm going to maybe come in here and tidy everything up so that I don't go crazy. And what I might do is console.log each and every one of these things so I understand what it's doing. Right, so maybe what we do here is we say console.log, and I'll put in dlat, comma, dlat. And then I'll do the same thing here, console.log, dlong. And then I come in here and say, console.log a, and then we'll, too many, console.log c, and same here. We'll just do log distance is d. All right. So we need to call get distance from lat long in kilometers, and we need to pass in the previous latitude and longitude and the new latitude and longitude. And maybe they're it shouldn't matter for us, right, which order we put these in, because we're just trying to see how far is it between these 2 points. But maybe we want to, when we're thinking about rewriting these ourselves, we want to put it as previous latitude, longitude, new latitude and longitude. Maybe we want to change the variables to be an object instead of, like, maybe we don't want to pass in 4 variables. We want to pass in a coordinates variable for the first one and a coordinates variable for the second one. So let's think about that as we explore. So we're going to come in here, right? We've got our latitude and longitude. We've got our old latitude and longitude. Let's just, when the page loads, let's just run this out and console.log it. So we will call, right? And we will say old lat, old long, and we'll say coords.latitude, coords.longitude, right? So we're taking the variables that we already have here, right? We've got the old ones on this part. We put it there. And we're taking the new ones that we're getting from the page load, from the actual browser itself, and we're just going to run this and see what spits out in our console, right? dlong is not defined. Did I use the wrong? Yep, dlon. He calls it dlon here, right? So we can see it starts off with dlat, whatever the degrees to radians here is doing latitude 2 minus latitude 1, and then converting it to, so latitude, let's math this out, right? So 33.500722, right? Is that our first one? It was lat 2, which we had as, oh, the current. So we're going to do current minus, right? Yeah, so let's just do 33.50072211 minus 33.50072222, right? Which gives us this infinitesimally small number, and then we times that by math.pi divided by 180, right? So we know that math.pi is like that magical number that talks about like the relationship of the radius of something in a circle to its diameter. So I think what they're doing here is they're converting this little slice of pi between these two coordinate systems to a circle, and then dividing it by half so that we can say that, like, on this circle we've got some degree in here, right? So that's the degree between each latitude and longitude. Does that make sense to me? Maybe. Times math.pi divided by 180, right? So that's giving us, yeah, one of those numbers, 1.7, right? Cool. All right, that makes sense. And I must have typoed some math number in here because this is not lining up with what we had here. But it might have gone the other way as well, right? Like, maybe it was this one. 507222, right? Minus. And we know that we can chain some of this stuff together, right? So where we had that magic number in here, we can do times math.pi, right? So we go times math.pi divided by 180. Oh, yeah, there we go. Now we're getting, okay, so it just changes the sign of the number. That's interesting too. I don't know if that will break stuff if we change stuff around, right? So we can see that the distance here is 0.0086 kilometers, right? We know how, like in Andrew's example, right, a kilometer, we maybe want to talk about this in meters, or we might even want to convert to feet. So just to make sure we're kind of in the ballpark of interesting, this algorithm gave us 0.00862. Right, let's just multiply that by, or let's divide that. So a kilometer is 1,000 meters. So if we wanted to convert this to meters, let's multiply it by 1,000, right? So let's do this times 1,000. And we can see that we are like 0.86 meters is the distance between those 2 points. So maybe let's change these distances to be a little bit more larger, right? We made a very small change to our distance. Let's make this like 6 and 6, right? And so now we can see that our distance is a bigger number. Let's change this to meters again. Times 1,000. We can see that's 13 meters away. I don't know if meters, like, I don't think in meters when I'm playing golf. We usually think in feet, right? So we probably want to convert that to feet as well, as we're playing with this. But it is spitting out a distance. It's doing some really cool math between the two latitudes, between the two longitudes, turning it into a degree instead of a radian, which was another math term. And then I don't know what A is here. Let's maybe see if we can figure that out. A. What is this A? So this is doing something. And I bet you if we if we understood this Haversine formula a little bit better, it's probably one of these crazy math steps in here. Let's see if we can find a better Haversine implementation. So let's look up Haversine in JavaScript and see if they've done a better job. That's the same one. So it looks like this guy stole or borrowed, gently borrowed. Right, he used the same A, C, D. Right, that should be like a warning sign. This guy didn't take the time to understand what's going on here either, which is probably why he's having similar issues as the previous guy. Right? Oh, I guess maybe that's they probably all stole it from here. Interesting. Okay, cool. So we're on to something. Let's see if we can find a better implementation that we can borrow. We'll just open up a few different tabs. Okay, that's the page we're on. Okay. That's the same. And maybe not. Maybe this is maybe in the Haversine or in the pure mathematical world, this is like the alpha and this is the delta. Delta means like the distance between two things. So maybe they're using D to mean delta. Yeah, see they're using, okay, they're explaining it to us. All right, this is neat. Okay, so oh, yeah, so now we can really understand what's going on. Oh, and these people do a little bit better job, right? So they're talking about the delta phi is the radians. Cool. All right, so I think we know enough now. Yeah, everyone's using A, C, and D, seems like. And if you are a math geek, then you'd probably understand what a lot of these things mean, right? Some of these thetas and deltas. All right, but we know enough now to right, we've verified this is working. Now let's implement this in our own words. And so a few things jump out at me, like we can probably stop logging all these console.logs. Let's just take them out for now so that it does not muddy up our screen. Okay. All right, we got a degree to radian. I'm probably so let's think of this. Our actual requirement is let's get distance between 2 points because we're building a golf app. Andrew, what do you think here? Feet is probably the more accurate. You care about driving distance in feet.
Yards.
Yards. Okay.
Yeah.
In 2 points in yards, right? And we know that how many is 3 feet in a yard? Okay, cool. So let's maybe look that up, right? So we're getting the radius of the Earth in kilometers. What would happen if we change this to radius of the Earth in miles? 3,095, right? Let's just check this, right? If we punch in this here, and let's maybe just call it 3959. We could do 0.8. Let's do 3958.8. All right, so this is the radius of the Earth in miles. All right. In theory, this should return, if we log it out here, okay, 0.008 miles. Let's look at radius of the Earth in feet. Radius of the Earth in feet. Okay, that's an astronomically large number. So maybe we need to see Haversine in feet. Because we need to get it into miles times 5. There's 5,280 feet per mile. So let's go back to miles, right? Miles is here, and then all we need to do is if we did this, right, times 5280. That's the distance of feet in miles. In theory, if we console log this now, we can see this is 45 feet away, which if we divide by 3 is distance in yards. So we've driven the ball 15 yards. 15.23 something repeating yards. Okay? Does everyone understand what we did here with the math? We're doing unit conversions, and I don't know the distance of the radius of the Earth in miles off the top of my head, so I have to go look this up. And this may or may not be off, right? We might want a more precise number here, especially for something as small scale as golf. But I would also be willing to bet that the accuracy of our GPS system is probably plus or minus 20 feet or 15 feet or 10 feet, right? So we might be off a yard or two. And the real world way to test this would be to like, let's run this on our phone and then move around a couple different places and see if the measurements are like, what is our precision here, all right? Oftentimes, especially when we're dealing with web development or mobile app development, we're just trying to get close, right? Like we're not building a guidance system for a rocket here. This is, hey, I drove the ball, how far did I drive it? And if you're plus or minus a few feet, it's not the end of the world, as long as you're consistent with how you do it. So, all right, so we know how to change that. So let's say, magic radius of Earth in miles is 3958.8. What was it before in, right, it was 6371. We'll just take a note here in case we maybe want to make our golf app available to people that live in Germany and they play golf, but they think in terms of meters. So maybe we make our function a little bit better here. Is the magic radius of Earth in meters, in kilometers. Okay, so we've got these. This is a magic number. We need to like keep this and track this. So let's just say, let's just rewrite our own function. So let's say like get distance. Right, get distance. Right, and instead of doing lat one long one like this, I think we can do better. Right, like we know we're going to be operating on, a chords object that has latitude and longitude already in it. So maybe let's just say we're going to say chords 1, and chords 2. Right? And it doesn't matter which order these coordinates are put in here. We'll just say like old chords, current chords. And then maybe what we want to do is add a third argument that is like, like units. Right? So units will be something like units is optional and means meters or yards. Right? Maybe that's the direction we want to go. So let's start implementing this. So let's we need to have something in here, right, that says like units, if units is maybe the default is yards because we're building this for American golfers first. So we'll say if units is provided and says meters, we use a different magic number. Right? So let's just go in and start writing this. We'll say var radius equals, let's put in the default 3958. Okay, and then, right. So right below this, right, we've got our radius here. We say if units, right, if is not equal undefined and units equals meters, we'll say radius equals, what was it here? 6371. Okay, so that changes whether we're doing this in metric or imperial. Cool. All right, we still need a degree to rad function that is going to do this information. But we're here in JavaScript, right? JavaScript lets us change the behavior of numbers, right? We've got a degree here, which is lat2 minus lat1. So that's going to give us some degree, right? This is going to be a number. Let's create ourselves a helper function that operates on any number. So let's just say helper function to provide degree to radians, right? I would prefer to write something that we can use usefully rather than relying on a function like this. We can put this directly on the number object itself, right? So we can do something like number.prototype.deg to rad, and we'll say function. And whenever we're operating on the prototype, we're adding this function to every number that will exist in this browser. So we can just come in here and say, just to check to make sure we're on the right path, we can say console.log this, right? That's going to be the number here. So if I come in here and I say, 5.deg to rad, did we save here? Var num equals 5. Num.deg to rad. Yeah, we can see that it's a function now, and it's going to spit back the number 5, right? So this is that number itself. So, all right, we just need to do, return this times math.pi divided by 180. So now we've made it so that all of our numbers on this page in JavaScript have this function available to it. So if we ran, right, what was the next thing, right? Lat1, right? We can do, if we did, we have this old lat, right? Minus chords dot latitude, right? That's the math we're doing here. So if I go like this, right? That's a number. I should be able to go deg to rad, and it's going to spit back that number that we were getting from this function. Right, so we got this part handled now. Let's delete it. We don't need that anymore. We've implemented this in a better way. Okay, cool. All right, so we need to do, so we'll say the degree, let's just do var degree lat. Okay, but here's an interesting thing, right? Like we're storing this in a variable that we're going to use in a bunch of different places. So we maybe want to let's keep implementing this. So we'll just say degree lat equals lat 2 minus lat 1 dot deg to rad. Okay, and we'll say var deg long equals long. We changed our variables here, right? So these were doing lat 2 lat 1, but we're going to assume that this is chords 1 dot latitude minus chords. Let's keep the same order they did. Chords 2 minus chords 1 dot latitude, right? And then the degree long will be chords 2 dot longitude minus chords 2 dot longitude dot deg to rad. Cool. So we got this part handled. So our get distance function that we're writing ourselves is going to take in a coordinates object that we gotten from this the navigator geolocation get current position function directly. So we'll get that. We'll store this object, and then when we fetch it again the next time we press a button, we're going to get another one of those objects, and we're just going to pass that in directly. Cool. Did everyone kind of follow along? Okay. So now we have this var a, which is this crazy thing, right? So we'll just copy this in directly. We know we need to change, deg lat plus. Okay. We already know that degree to radian. We've written this ourselves, so we would need to change this to chords 1 dot latitude. Right, that's a number, and we'll say deg to rad. And then here, same thing. Chords 2 dot latitude. Was that lat? Yeah. Yeah. So here we'll say chords 2 dot latitude dot deg to rad. Okay, and then deg long. Okay, so we're at the exact same spot we were before. And we can kind of see it's doing the math. Okay, so this variable that we ran up here, we stored it in deg lat. We're using it here, and then we're using deg long here, and then we're adding that to the cosine of the latitudes degrees to radian times the second one. Okay, cool. So that's that part, and then we need to do 2 times math dot square root a, right? So this value we're getting here, we're going to do that. Right, so let's just copy this up here because this is pretty close to good, and we'll say var c equals, and then what we actually return is just r times c, and we'll keep this in here. We want this to be right? So instead of putting this in a variable like they did here, let's just return it. No sense bringing a new variable in here. Okay, so we're seeing an error now, and it says deg to rad is not defined at get. Where's that? Oh, because we took out the function, right? So now that we've recreated this entire function, right, we don't need this one anymore. So the place where we called get distance, we can now just say, right? Instead of calling it this way, our version is get distance, and we pass in chords 1 and chords 2. So let's try that. Get distance, and we'll say chords. Right, that was our original one, or this is our current position, and if we had a previous one, right, it would look something like, chords. Latitude is old lat. Longitude is old long. Okay, so this would be if we had a previous call to this button, right? Then we would have gotten a geolocation, right? So we can just simulate this. We'll say like old chords equals. And so this is the type of object that comes back. Obviously, JavaScript, the browser itself is giving us more information, right? We not only have chords, we have like accuracy and height and stuff. But for the purposes of simulating this, just to make sure that we understand what it's doing, we can very easily create our own little mini object and then pass in old chords. Right? So get distance is going to be using our function now, and it returns a value. So let's just maybe console.log, and we'll say distance, and we'll put in this, so that when we call it, we can just make sure that we're working. Cannot read property deg to rad of undefined at get distance. So we got a line of code here that's incorrect. Chords 2 dot latitude. Oh. Chords 2. Oh, because we put it into a. Right? So this is what our fake object should look like. Cool. We still have another error at line 26. Do we have a typo here? Let's take a look. Deg to rad. Let's save and reload. Okay, so let's just come in here and console.log chords2.latitude. Console.log chords2.latitude. And just make sure that we've got a value in here before we error. Alright, so we do. And we'll say, deg to rad. Why is it not running on this one when it was running before? Deg to rad. So let's just do type of. Make sure that this is a number and not a string. Let's do type of. Why is it a string? Okay, so we're going to have to make sure, for whatever reason, chords 2, we have a. Oh, okay. It's because we've never. We need to make sure that this is a number instead of a string. Right? We were talking about this earlier, and we never actually went through and made sure that we were providing correct values here. So let's just convert this to a string. Does anyone remember we have a function that we can use that will change a string into a number?
The parseInt.
Okay, let's try parseInt. All right, so we let's right, so we know that we have document.get element by ID, and what we call it, like old lat, right? Old lat dot inner text. So if I run parseInt on this, it gives us the number 33. Is there any problem with this? We've lost all of our precision.
Is there like parse float?
Yeah.
Okay, let's try that. Parse float. Perfect. That gave us exactly what we were looking for. So we need to just, when we get these values, we probably want to just do it when we capture it. Parse float. Now, this is only a problem because we're prototyping. When we're really using these objects, right? Like we're getting these chords elements here from our navigator geolocation object. These are coming back to us as correct numbers. This is really just hey, we're building something to test it with, and we put it on the page. The page is a string. So, but for the sake of making sure that we're doing everything correctly, we want to test it, right? R is not defined. Where do we have R in here? Oh, R, we changed that to radius because we didn't like. I don't like single letter variables like this. What does this mean? I don't know. I would prefer something that is better named. But unfortunately, all the Habersign implementations just have A, and this probably really means like alpha. I don't know what C means. Go ahead, Estrella.
On line 22, did you mean to subtract chords 2 from chords 2?
No, that's probably wrong. Good catch. We're probably going to be, we're playing our golf game. We're going to be like, this is incorrect. So let's see what it was originally. Yeah, long 2 from long 1. Oh, what did I do? How did I make it full screen? Oh, there we go. Cool. I hit F11 apparently. Chords 2 from chords 1. Yeah, perfect. So this should work now. And we can see that our distance is 008 yards. Or, right, that was 008 miles, right? We needed to change this to distance in miles. Maybe what we want to do is make a conversion function, right? So we'll make another one of these, number.prototype.miles to yards equals function. And then we can say, right, we know that there are 5,280 feet in a mile. So we'll do return this times 5280. And so that's going to give us feet. And then we want to divide by 3 to get yards. So if we do this math, right, get distance, what we can do is we can just do radius times c dot miles to yards. And that's a function. So 15 yards, right? Right back to where we were when we were playing around with it together. But now we've written this function that provides us, okay, here's a problem, right? We did some unit conversion up here. We said, hey, if the units is this and it's meters, this is going to be incorrect. So maybe what we need to do is also in here check down here, right? So we have to say if units is not equal undefined and units equals meters, right? We're going to return radius times c, right? In metric, it's super easy, right? Because all we would have to do, because this is giving us kilometers, is just multiply by 1,000, right? Else, right? And we can say default is yards distance, and now our comment here at the end is incorrect, so we'll say distance in yards. But it kind of, one of the really nice things about writing well-defined functions like this is that it tells us miles to yards. I understand what this is doing because I wrote something that tells me what it's doing. I don't even really need a comment, right? Let's take that out for clarity. The only thing that really matters is we just say like the default is yards. Right, and let's check it now with, okay, so that's distance in yards. Let's change this to meters. Let's see if our function works here correctly. Let's just say get distance, and we'll say meters. Okay, so it's apparently 13 meters. Is that correct? I don't know. Let's 13 meters in yards. 14. Wait, let's copy our 13 point. So this is meters. Yeah, 15.2. So we did it. We have a function that we wrote ourselves using an algorithm called Habersign that we didn't have to invent that calculates between 2 latitude and longitude coordinates. And we know how to get it's like super duper easy to get the latitude and longitude for where I am currently. Right? Like, it's not going to work as great on a computer. It was like within a few feet, obviously, from my current location. But on a mobile device, this is going to be pretty good. So, the next step for me here, if I was testing this, if Estrella was trying to impress Andrew with this code because they work together on this golfing app, the next step is they deploy this to some server somewhere, and Estrella would maybe go outside, and Andrew would, actually use this and see if it calculates the distance correctly. There's definitely going to be some precision problems here. Consumer grade GPS devices inside of your phones and stuff is never going to be accurate to inches, but it's probably good enough for a really good golf app. And the easiest way, we would have probably found our conversion, this little bug that Estrella pointed out, where this said chords 2 before. We would have found, if I hit a 200-yard drive, I'd be very excited about that, and then I'd be like, it says the distance is 100 yards. So we'd probably find, if we'd left that bug in there, we would have probably found it in testing, or hopefully someone with a sharp eye would catch that in a code review when Estrella says, hey, it's ready to be checked in, please review my code. They'd be like, this doesn't look right, you're doing chords 2 minus chords 1, and this one was chords 2 minus chords 2. Is that accurate? They'd probably ask a question and be like, oh, good catch. Any questions about this? We introduced a few new concepts, specifically this navigator object and then the geolocation functions in here. And then the other thing that I did that was maybe, we've kind of touched on this a few times, is everything in JavaScript has this prototype thing where we can add new functions to numbers, strings, arrays. We can do those things as well. So if I'm going to write a function that operates on numbers, might as well just add it to the number so that every number that exists can have this function available to it, rather than the way that was originally defined where he had a new function in here floating around. I like that it gives me this style of information stylistically, where I can say, hey, any number that we generate, I have a degree to rad function on it, rather than having to pass it. It's purely stylistic. Both are exactly the same thing. They're still functions. This is still doing the same thing that the other one was. I just like the way this looks. That's just personal preference. Any questions? No? Alright. It is 6:05. Let us take a break and come back at 6:20. Is that 15 minutes? Cool. See you guys in a bit. Let me restart the recording. All right. So we have this working now, right? We've got it so that it pops back. We could take in two sets of coordinates. We get, if we're thinking of this as like we're building a golf app, we start from the tee box. We press. No, I gotta
share.
I'm not sharing yet. I'm talking with my hands.
So, okay.
I will share. Thank you. Of course, I forgot to click the button. So we're starting from the tee box. We press, hey, start hole 2. Maybe we log the time. We hit the ball. Then we go to the next one. Okay. So one of the things that Andrew has been doing in his app as he's been building it, and this kind of just springs to mind because now we're capturing the coordinates, right? He's saying, how many shots did you take? But if we're using this shot distance calculator, we should know how many shots we take because we pressed, hey, shot 1, shot 1, shot 1. So every time we press the shot button, it can track for us. And we know that we can do, store this information in session variables. So let's maybe just play with how that could look if we were building this as a real world concept. So Andrew, definitely take notes because we're going to build a lot of your stuff that you're going to be building for you. Okay? Cool. All right, so we have this, right? We know that we have this mechanism that will let us calculate the distance between 2 points. So let's make this, just for the purposes of prototyping, let's add a button in here that is like, take a shot. And so every time we do this, because we're not actually on a mobile phone and we can't test this, we're going to have it just generate a random number so we can see a distance between the previous shot and the current shot, and then store that in some object. So let's make ourselves a button here, and we'll maybe come in here and say button ID equals shot, and then we'll say take a shot, right? Right. So we can see that our button exists. Oh, it's floating. So let's give ourselves a. Here, let's just add a HR style equals clear both, right? Because we're floating these elements, these divs down here, everything is floating. And if you remember from when we were learning about HTML, when we first learned about floats, like floating says, hey, don't do the regular HTML rendering, move this over to the left or move this over to the right. And so the button was floating. and using clear both, this attribute here is telling it to don't let things float past me. Okay? So we've got to take a shot button. Let's add ourselves. We're going to go to the add event listener, right? We know we need to attach an event on our button, right? And we all know how to do this now, hopefully. Document.getElement by ID. Shot.add event listener. And we'll say click. And we know we need a function here. Let's just do, like process shot. All right, we pass it in as a reference. So we don't put parentheses because we want the function itself to be listed as the click handler. Okay, so we need to write a function called process shot that will do something. All right, we've got all this math stuff defined. So let's make function process shot. Okay, it does not need to know anything. We're just saying that it will get an event, right? Because it is a click handler, but we don't need it. We're probably not going to use it for anything, so we can leave this blank for now. And so what does process shot need to do? A, it needs to say like store the current location, right? So wherever we're at right now, as soon as I click take a shot, capture that spot. Store it in an object. Store the current location in some array or object. We don't know yet what we're gonna choose here. And we probably want to like store the timestamp, right? Maybe that's interesting to be like how quickly did you play, and then wait until the button is pressed again, and then when the button is pressed again, we can say right. So we're storing the current location so every time we click this button, it's going to store the current location, maybe store a timestamp. I don't know yet, but then we're also going to say if there is a previous location, calculate the distance, right? That's pretty neat. So if we imagine we've got let's just say it's an array. We do let shots equals array. Right now it's empty. So the first time we do this, we look and we say, are there any shots here? The answer is going to be no. And so we're just going to store the current location, maybe a timestamp. Okay. The next time we press it, we're going to say, is this empty? And the answer is yes. So we're going to say, what's the distance between those two? Okay, so maybe inside shots is going to be each index in there is maybe going to be an object, and it's going to maybe say like chords, and maybe it'll say like timestamp, and maybe it'll say like distance, right? So shot 1 is going to have no distance because it's the first thing of the thing. But then when we get our second element, maybe this one will say shot 2 is chords, timestamp, and then this will have a distance, right? So distance can be null or not null, depending on shot 1 is this. And then we can calculate the total distance either by adding up each of these distance values or by looking at the start to end. Maybe we'll explore that as well, right? So like calculate the distance, store the distance if it was generated. And then, good. So process shot, this is really all we need. And this is kind of the format that I think we're probably going to go with. So let's put this in a comment so we can kind of see our structure as we go, and we'll just say let shots equals. Right. Everyone following along so far? This is kind of the thought process we're going through. I don't know what this is going to look like when we actually get in here and start developing, but this is how I like to write code because it helps me work through the problem as we go. So, all right, we know we can get the current position. So we assume that every time I press this button, we're going to get this, right? So in real time, this will be something we'll put in here and say like get current position. But what we probably want to do is cheat, right? Because we are not actually walking around with the phone. So let's maybe make a fake function that gives us some distance that's close to our current distance, because we already got like our real distance when we loaded this page. Yeah, so we're already calling this once, line 77, and it's giving us our current coordinates. We have a chords object in here that is storing where I'm currently at. But we want this process shot button to take these coordinates and maybe tweak them a little bit so we can pretend like we're playing real golf. Okay, so let's make a fake thing. And so we'll say fake function to let me test my golf game while I'm on a computer. Okay? So we'll just say, all right, we know we have chords. Chords has our current coordinates. Right? And we know that if we change, so here's our current position, it's 5007. If I change this to 5006, it ends up being, a different, kind of 15 yards away, give or take. So I think we need to assume that like the kind of the level of precision that this needs to have is maybe like the first 3 digits will always be the same, and then we assume that while we're playing this fake golf, maybe these last couple of digits change, or maybe we say the first 2 digits of the change. So let's maybe test that out real quickly here. Let's see how far away we are. Let's change this back to not meters. Let's test our assumption here. Right, so 5006. What if I make this 501 and 504? Right, what is this going to give us? Okay, 56 yards. So that's still kind of not even enough precision for real golf as well. So maybe let's change this to like 5. Let's see what happens if we change this second decimal place to like 1. Right? Okay, that's 1,000 yards. That's way too far. So we're kind of working in the space of these 3 digits. Right? So this is the precision we care about in this golf game, and anything that goes kind of above and beyond that is extra little bits of precision. So we know how to generate numbers, right? So we can let's just copy some of this over, just so we have some reference on this page, right? And let's say our current chords is that, comma, this. Right? So this is our current. So we really want to just say like, generate, but it's the third place we're changing, right? So it's 500. All right, we can make this third number anything. So, yeah. So let's just say, no. All right, let's generate fake numbers that go in here. Okay? All right, so let's just make ourselves a quick little function. We'll say function fake chords. And we'll maybe just return, an object that has latitude. We say 3350 plus math.random, right? 0 to 1 times 1,000, right? So that'll give us, right, should give us some kind of fake number, right? 473, and we can maybe just do parse int here to give us some random number, right? We don't care so much about precision. We don't care if it's inclusive of the 0 or the 1. We're just trying to generate some random numbers, and this looks pretty good. So let's do this, but we know that if we actually add this, we're trying to do this as a string. So let's go like this, because if we add 3350, right, 3350 plus, parse int math.random times 1,000, I've just made 27,000, right? Because it's assuming that I want to add 33.5 to that random number we want. But if we come in here like this, plus, if I'd done it, it's plus, right? That's obviously wrong. But I can turn this into a string by just saying like that. Oh, that adds a space. So let's just take the space out, right? Perfect. Okay. Oh, because I put 50. So let's just do 500. See what that does. Okay. Let's see if we can change this to a string in another way. Maybe if we change it to a string first. So let's do plus. Okay. So because this number was 33.50 when we added math to the end of it, even though we were converting it to a string, it was assuming that we didn't care about that last 0. So we're gonna have to cheat it by saying 501, that's fine. So this is good enough for us to use to generate some fake positions. So we'll say latitude is string plus 33501 plus math.random that. So that's our latitude, and we'll do the same thing for longitude. And we'll say plus negative 82.51 plus math at random. So if we run this here, just to make sure that we're still getting good numbers. Ooh. What do we get here? Oh, we forgot to put it in parse int. Right, parse int. Yeah, okay. That's giving us some interesting results. Alright, that's neat. So let's make sure we put both of these in parse int. Parse int. Alright, so we've got a fake chords function. And every time we click this button, right, we would normally call this, right, we're actually going to get the actual coordinates, but for now, we'll say call the fake function until we can test on mobile. So let's just say fake chords, which is going to return us the same type of data that we're getting from Navigator, right? And so we can just say let current pose equals that. And maybe we say current chords so that we know we're definitely talking about latitude, longitude. Okay, so we got current chords. Let's just console.log this to make sure we're on the right track. So we click this button, we get latitude, longitude, right? And you see that we're getting different values each time. Neat. That's kind of exactly what we wanted, to be able to prototype. I'm walking around on a golf course, pressing this button, taking a shot. So we get our current chords. That's great. Let's store this. Let's skip the timestamp thing for now. We're going to leave this as an unanswered question. All right, so we know we have a shots array. If there was a previous shot in here, we want to take the most recent one and calculate the distance, right? So let's just, all right. So before we store it, right? We said store the current location in this array. But if we store this in here right now, like shots.push current chords, then we have no way to calculate the distance. Or we do, but we're going to have to like operate on this complicatedly. So maybe what we really want to do is say get the current chords. And then if there's a previous, then store the distance if it's generated along with the newest distance or newest coordinates, right? So we're going to do all this calculation stuff first if there's something in here, and then at the very end shove this current chord. So maybe what we want to say is like shot info, right? So if we store shot info in shots right now, we have not checked to see if there's a thing. So we need to move this down. Perfect. So the last thing this function will do is store this in this array. So we're going to come back to the timestamp. So let's just, how would we check to see if there was a previous shot in this shots array?
You could do an if statement that iterates if it goes to a certain, if once you iterate through the array, if there's something in the array, then it.
So you want me to loop through
it
the
shifts
array?
to previous, or loop through the array. Yeah, sorry.
Okay, so for bar I equals 0, I is less than what do we put here? Array shots dot length I plus plus. So this will let us loop through it, and then if there's anything in here, we'll have it. Is there maybe an easier way? I think you're kind of on the right path with this. We're just trying to check to see if there's anything in the array, right? Can you think of a thing we can use here to see if there's something here?
If shots.length.
Yeah, perfect. If shots.length. This is going to be 0, right, if we do this right now. Shots.length. Shots.length. It's going to be 0. If we push in a shot, right, shots.push, we'll say like, something. Now shots.length has 1. So the very first time we click this button, process shot, is going to be 0. So we don't need to calculate any distance. But when there's something in there, right? Shot 1 was from the tee. All we care about is where did we start from. Shot 2, we'll say, hey, there's a shot in here. Tell me the distance of that previous shot. Okay. So how do we calculate distance? We wrote this function, get distance. Maybe we would just leave this as a do for now. Like calculate the distance of the previous shot. Okay. Store that in shot info. Okay. Okay. And that was kind of this, store the distance it was generating. So we can take that comment out because we put it up here. Calculate the distance and then store it in shot info. And then we already have that shot info already has the coordinates, right? Our fake coordinates. And so then the final thing we do is we push that into shots. Okay, so we don't have. Oh, let's take this out. All right, we don't have our calculation stuff working, but if we've played our cards right here, which we did, because we were good programmers, click the button. It's gonna get fake coordinates for us and push it into an array. So we can just verify this. Let's click it a few times. We can type in shots, and we can see, hey, there are 5 entries in here, and we can see that they all have different latitude and longitudes. Cool. And then if, so now really the thing we need to figure out is, okay, if, shot 0 goes in, that's our first shot from the tee, no distance is calculated, but we need to calculate distance from 1 to 0, and then from 2 to 1, and then from 3 to 2, and then from 4 to 3, and then maybe we want to say like 4 to 0 at the very end of this, and say like, what was the total amount of distance we traveled? Could we have been more efficient by not taking 5 shots on a par 3? I don't know. Maybe that's interesting, maybe it's not. That's something to experiment with inside of Andrew's app when he's actually building it. I don't know what kind of data is going to be interesting here. We'll probably just care about what was your driving distance, what was the distance, maybe if he does have good mapping data and he knows that like this is a 170-yard hole, you should be able to theoretically get this from, if you had a hole in one, you want 170 yards. Anything over that is some kind of thing that he needs to work on in his golf game. Okay, so let's figure out, let's calculate the distance and put that information into shot info. So we wrote this function already. We have our fake coordinates. If there's something in shots.length, we want to get the previous one. So what can we do here? How can we use this function, get distance? And let's just copy this up here so we know this is what we want. This is kind of our function definition. So we've got an array of shots. How would I calculate the current shot against the previous shot? Estrella, what do you think?
I know the only thing running through my head is wrong right now.
Well,
it has to do with elements. It's last child. It has to do with elements within a page. So I know it's wrong, but for some reason, it's all that I can think of.
You're exactly on the right path, though. We know we have a few ways to access values in an array. What is one of the ways we learned that's a function of an array? It's in the array prototype that would let us take something from the end of the array. We want to get the last shot, obviously, always, right? So we learned a function.
One is shift.
Okay, shift.
Or pop.
Pop, yeah. So pop does it from the end. Shift does it from the beginning. The problem is, those are destructive, right? So pop is going to remove that element from the array and then give it to us, right? That might be interesting, but then we'd have to make sure that we would actually, if we were writing this as our code, it would have to be like, okay, now restore, resave the object back into the array that we just popped off. So there's maybe a better way to do this. How else can we access, if I wanted to we know we've got shots, and it's got 5 shots in here right now. If I wanted to just pull out the second one, how could I write that? I just want to see what the second one has.
It would just be shots square bracket 1.
Yep, that's the second shot. Yeah, perfect. So if I always want to get the last one, right? Shots has a property that we just checked, shots.length. So shots.length is 5, but we know there's only 4 elements. Can you guys think of something we can do here inside the square bracket method? Shots. If I always wanted to get the last one.
Dot length -1.
Is that our last one? 4, 8, 2, 5, 1, 1, 1. Yeah, that's exactly right. Shots.length is the total size of the array, so it's going to be like 5. We know that it's 0. It starts from 0, so shots.length -1 is always going to give us a point to the last array. So we can use this, right? So let's just take a note. Shots.length -1 is always going to be the one we care about. Right? We want to pass this to get distance, right? So let's just make a variable, right? So let shot distance equals get distance. Well, we want to probably do shot.length -1, and then comma shot info, and that should be it, right? If I console.log shot distance here, right? Every time I click this button, we should see a. Go ahead. Oh, Leah spilled water everywhere. We'll give her a second. We'll fix this while she's gone, because the reason this is broken is interesting. String. So it says number here. Get distance. What is get distance returning to us? So something we're doing here is breaking this. So let's say, okay, so the first time we do this, does shots have anything in it? Why are we putting out a distance here? Oh, is that? Okay, that's the distance between these two. Let's turn this off. Okay. Where do we have number coming from? Current position running. Let's turn this off as well. And then we have number somewhere. Let's just look for console. Okay, type of chords2.lat. Oh, I know what the problem is. It's the same problem we had below. Because we're faking this, this is a string, right? Okay, so we need to parse float the end result of this string that we're generating. Parse float string. So we can't use our degree to radians function because we faked this, and so now we can see, hey, we're making 600-yard shots, that probably means that we probably would need to tweak our fake coordinate system, but in theory, if we look at our shots array right now, right, like we took 16 shots, our little assumption for what our latitude longitude randomizer could be was a little bit wrong, but not wrong enough to like make us stop. So it is 6:48. Maybe we'll give Leah a few minutes. Now would be maybe a good time to break, and when we come back, we'll do some more stuff with this. So it is 6:48. We'll call it 6:50. Come back at 7:05. The recording. So I don't know if you got to see this, Leah, but we had an error in our code because we have this fake chords function, which we turned into a string so that we could add these numbers together, so that the numbers would be added to the end of this coordinates. And so when we were running this originally, it was telling us get degree to rad is not a function, and the reason for that is because this was a string, and this needs to be a number, right? Because we put this on number.prototype. So the correct solution, the correct fix, is we need to put this as parse float and wrap that whole thing in it. But I also had, while we were away, I was like, I'm the type of developer where I've made this function to help myself. One thing that jumped out is I have this option right here. I can do string.prototype.deg to rad, and I can put a function in here, and I can say, console.warn or console.error, maybe even like, hey dummy, you forgot to make your string a number, right? So now if I click this, I left the word parse float up here. Okay, so now if I click this, it's going to warn me, hey dummy, you forgot to make this string a number, right? But this is also, like, all joking aside in this type, right? I can just make this string.prototype.degreeTorad. I can make this return parse float this dot deg to rad, right? So if I parse float the string, which we were doing up there, and I return degree to rad, now it works perfectly, and I don't have to do this here. So now I've made this so that the string has a function called degree to rad, and the number, which is actually doing the math, has a function called degree to rad, which is, like, now we've covered both bases, right? So that if I ever made a mistake in the future, right, like, if we look at shots now, shots should, yeah, theoretically, right, work correctly. We've fixed it by correcting our mistake that we've made twice now, by just giving ourselves another function and attaching it to the prototype of every string that exists. So that's, we could have done it up here with parse float just to be correct, or knowing that we're writing JavaScript that we're going to probably use over and over and over again, like, we're just adding to our toolbox of functions that help us do things correctly, right? Cool. So where we kind of left off is we've got our process shot. We're getting our fake coordinates, but we know that when we are really doing this on a mobile app, right, we're going to actually use navigator.geolocation get current position, right? We know how to get the actual coordinates, but we got our fake coordinates here, where we got our thing. We know that if we've got something in this shots array, we want to do something. Okay, so we're generating this distance. That was all working correctly. So let's just save shotinfo.distance equals shot distance, right? And so then where we were console.logging, we can just take this out now because that's working. And now we see that our shots array will have, the first shot is going to have nothing, but every consecutive shot, we look at shots, will have a distance attached to it, right? So shot 0 was from the T. We went 389 yards. That was where the next, or maybe what we need to do is have the distance be applied to the shot that it was from. That's interesting. What do you think, Andrew? Right, like, if we're looking at this from a pure data model perspective, shot 0 had a distance of 389 yards. Shot 1 had a distance of 317 yards. Shot 3, so maybe we have this in the wrong element.
I would see it more as from the starting point.
Yeah, so rather than do this on shot info, we really need to put this on this element, right? The previous one. Okay, so if we're on shot 0, this is skipped. If we're on shot 1, right, we're in index 1, shots.link will have 1 on it. We're calculating the distance. Rather than applying the distance to that one, to shot info, we probably need to put this on shots, and then shots.length. Oh, I put shows. Nice. Shots.length -1, and then we say dot distance equals shot distance. Okay, and then instead of storing that in shot info, we store the distance in the previous shot. All right, so now let's test this. Click it a few times. Shots. Yeah, okay, this is really cool, right? So shot 1 was 419 yards. Shot 2 was 410 yards. Shot 3, 276 yards, and then shot 4 essentially was like in the cup. And that probably needs a distance as well, if we're being honest with ourselves, right? Like every shot will have a distance. So that's maybe something that's missing, which is the final one. We'll think about that. We'll leave ourselves a to-do. To-do, this is working, but we're not calculating the distance on the final shot. Okay, so that's something maybe to think through. But we are correctly putting all of our shots in a single array. And then this really points out, like, to me, now that we've gotten to this stage and everything is like, oh, like this is actually working. Okay, we know that we have 4 shots. Okay, this data object, where it's got, you know, each shot is its own element with information about it with coordinates. This would go very nicely into because what we get here, right, is we can say, you know, this shots thing is like a single hole, and if we wanted to see how many shots do we make, we could always call shots.length. Right? It's a par 4. We hit par. We got 4 shots. So we maybe need another button that is like go to next hole. So let's do that. Take a shot, and then we'll say button ID, and we'll say next hole. Next hole. Alright, that makes sense to me. So let's go ahead and in our same spot where we're putting these event listeners, let's say document dot get element by ID next hole dot add event listener click.
I think you named it next hold.
Yep, good catch. We would have found that out in the console when it told us that that element didn't exist. But thank you. Next hole, and then we say you know, next hole. Right? You know, keep it nice and simple. So we need a next hole function. Right now, this is going to do nothing because that function doesn't exist. But it's going to treat it as if we were clicking on the element. So let's come up here and let's say, all right, process shot stores the shot information inside a hole. Okay, and then we need a function next hole, which stores the shots of the hole, clears the shots array, and displays this info. Okay? So we click next hole. Right, if we console.log this, console.log going into hole, right, and we'll probably want it to say hole 1, hole 2, hole 3, something like that. So next hole, right, that's working. So we've got shots. Let's maybe, you know, to me it says maybe like holes, or maybe we call this game. And I think this should be an array too, right? Because there's going to be 18 holes, or maybe you're playing a 9-hole course. Maybe it's 9. It doesn't matter to us. It just knows that this shots object that we're building with process shot is going to eventually, when we click next hole, go into game. So we're going to start with hole 1 is going to be index 0, hole 2 is going to be index 1, hole 3 is going to be index 2, and so on and so forth until we get to 18 when the game is over. Or maybe you're playing, you know, a 36-hole scramble or something, so it's actually 2 18 holes back to back. So we don't care how many holes go in here. We'll probably need some button at the end that's like finish that will say like your score for today was X. Okay, so the easiest thing, maybe just kind of what jumps to mind is right, we gotta take current shots, store in game array, and then clear shots array. Right? Pretty simple. Like this on its own, in theory, if we click a bunch of shots and then we click the next hole button, we'll save that into the game array and then clear everything out. So we're right back. So let's start from there. Take current shots. Yep. So we'll say we can kind of combine these two comments, like and. Right. So let's maybe go shots, or excuse me, game dot push shots. Right, that's going to store it in the game array, and then we can just go shots equals, right, clears it out. So let's go, you know, four shots there, a couple shots there. Let's look at game. Game has, oh, I clicked it 5 times each time. Right, now we're on par 3. Great. If I look at game, we can see that we have an array, and it's got, you know, the first one was 5 shots, right? The second one is 5 shots, and the third one is 2 shots. Cool. So we just built golf in like 2 lines of code. All right, so let's maybe, now that we've gotten to this stage, let's let's think again about our presentation, right? So we've got this, we've got these boxes here, so we can recreate this to like show our shot information. So let's maybe leave ourselves a to-do here. And it's like to-do, we'll say something like update the page to display our scorecard. Right. So let's make ourselves a scorecard div. We'll just float this, so let's just say div ID equals scorecard. Okay. Div. We now have been using this like this same style for all three of these divs, so let's just steal this. Okay, and those are the only divs on the page, right? Yeah, so let's just give ourselves a style real quick, and we'll say style type equals text / CSS, right? So we'll use an inline style. We know we're going to want to make this a style sheet that is actually in a CSS file, but let's just make sure we're happy with things before we go on. Right? So every div will have this applied to it. So we've got a scorecard here. We'll say, you know, H2 golf score. Okay. And if we look at our page, yes, we have a golf score div. All right. Let's actually take out this. We don't even need this anymore, right? Like this is our testing code. But we'll just have ourselves a scorecard. All right, great. And now we're getting an error, you know, because we took out elements that our page was relying on to do some stuff. You know, let's put these back so that we don't have to fix that yet. Let's just come in here and say, right, great. All right, so we're gonna have the golf score here. We can go into our JavaScript and we need to like turn off this stuff that is using those elements, but we're gonna ignore that for now because we're still building, we're still prototyping and playing. But we do want to come in here and say, update the page to display our scorecard. So every time we push shots in here, we probably want to just update a list. Maybe so this is like a list of like hole 1 something, hole 2 something. So let's just write ourselves a little function because we don't know yet what we're going to do here. But let's just do like update scorecard, and let's just push in shots before we clear it out. So update scorecard is going to take our shots array and do some information here, right? And it also seems to me like we were talking down here, if you remember, like this is working, but we're not calculating the final distance. So maybe next hole is where we would calculate that final distance, right? We've got the final element. How big was our last shot? I don't know. Whenever we press next hole, like this is presumably like, hey, we got the ball in the hole. You're gonna click next hole at the hole when you pull the ball out. So now we have the lat long of the final spot, which would let us know how far we putted, right? So if we did like a 60-foot putt, that's interesting. So let's maybe take a note here that to do, and we'll say next hole is called at the flag. Use this coordinate to calculate the length of our final putt. Neat. Okay. All right. So update scorecard. Before we come back and try and tackle any of these to-dos, maybe we let's just start with something extremely simple. So let's just create a new function. Function update scorecard. And we know that this takes a shots array of shots, and we know in here, you know, we've got an element that says scorecard. Right, scorecard element needs to be updated. You know, so there's a few different ways we could do this. We could very easily say that like we really have a unordered list. And maybe the unordered list is actually what's called scorecard, right? Because we want to operate on the actual shot count. Oops. And so it would be like, you know, li shot. Oh, maybe this needs to be an ordered list, so we get numbers for free. Yeah, that'd be cool. So we could say, you know, shots you know, 4 shots. Ally, 3 shots. Right. So yeah, that's kind of working, right? So like hole 1, 4. So maybe that's the first thing we try. And we come in and say something like, alright, so scorecard, which is an ordered list, right? Just so we put it in here so we know what we're working with here. Needs to be updated. So, alright, let's just try this, right? So we know let shot num shots equals shots dot length, right? Just so we can kind of track along with what we're doing. Okay, and then maybe we want to say like let longest drive is some number. We're gonna have to loop through the array to find that out. So let's say get longest drive, and then create a new list item and add it to our scorecard OL. Alright, we know how to do that too, right? Alright, so let's go from the, right, we got a number of shots here. That part is super easy and free because we have an array of shots and we can just count how many were in there. Longest drive. Let's loop through an array, right? So we have our shots array. Let's do for var I equals 0. I is less than shots dot length I plus plus. Okay, how can we see, right, we've got a distance value in the, right, this is an object. If we console.log this right now, shots, if I click next hole, did it reload? Update scorecard. Oh, I gotta take some shots first, huh? Take some shots, next hole. We can see that each one of these things in this loop, in the shots array, is an object, and it has a distance in here. So how would we write this to see what the longest drive is? Right now we have longest drive is set to 0. Who can think of a way to solve this? Leah, what would you write?
Can you repeat the question again?
Yeah, we have our shots. We want to find out the longest shot of the hole. What would we write in our loop here to see if the longest to set that longest drive? And we have
If shots square bracket I is greater than longest drive, then longest drive is equal to shots I.
Okay, you're really, really close. Shots I is an object that has some properties in it. So shots I is going to give you an object.
Dot distance.
Yep. Perfect. And we want to put this here, right? So now we figured out with this loop, when we click next hole, we're going to have a longest drive. And so now let's just console.log longest drive. Right? So we're going to loop through this array. Every time we click next hole, we're going to calculate the longest drive of that hole. Cool. All right, so it seems to be working. If we looked at shots, or game rather, because we stored it now, game. Let's just make sure, hole 1 was 482. We thought that was our longest drive. Let's just double check. Yeah, okay, 482. Apparently we had a very, very, very long putt to finish things out. Okay, but now we're seeing maybe some interesting problems. All right, so we know already that we aren't calculating the distance of the last one. Now I doubt that you're going to have a longest drive on a putt, but what could happen is this might be a par 3, and your first shot is hole 1, 150 yards or something. That would be excellent, right? We celebrate. But we know that, like, let's reload. If I just do 1 and I click next hole, I look at games here. Game, right? So this is another bug with our little to-do. We're not only are we not capturing our putt, if we have a hole-in-one, we don't know how long that hole-in-one was because we're not calculating distance. So maybe let's solve that now, because we're kind of at an interesting point where we're doing something. We're going to update the scorecard. Let's go into our next hole button. Right. So this is a perfect time, right? We've clicked the thing. we need to use this coordinate to calculate. So we'll do the same thing here. We'll say, we know we're going to call navigator so we're at the pin, right? That's where we are at the pin at, right? We go pick up our ball, we press next hole. But we need fake coordinates, so we'll just say, fake. We'll just do this, and then because we've done this already, we'll just do get distance, right? So this is shot info, and then the current array value, which has nothing, it's just gonna have 1 right now. So if array length is 1, then shots length minus 1 is 0. So it's gonna be like our hole in one shot. And then we need to do the same thing. We need to say, hey, store that distance here. So that, I think, has solved this completely. Let's try it. Take a shot, next hole. And then we go to game, and let's see, we should have a distance in here. Perfect. And if we test it with like a regular thing, let's say this is we do a par 3, I click next hole. Let's look at game again. We should now see that, each and every one of these things in here has a distance. So we solved that to do. We can take that out. So this is good. Okay. But let's maybe leave this note, right? Next hole is called at the flag. Use this coordinate to calculate the length of our final putt. And then we'll leave this. We know that we're going to want to use navigate. So it's no longer to do for us. We've calculated it, but we're telling you why we're calculating it here. So this comment is still helpful to us, right? Like next hole stores the shots of the hole. And maybe we even put a note up here which says next hole is meant to be used at the pin, right? So when we're building this application, maybe there's some kind of tutorial that we show the user at the beginning, which says, shows how to use it. It's like, at the tee box, press take shot. When you get to your ball, press take shot. When you get to your next ball, press take shot. When you get to the pin, press next hole. So that we've captured all this information at the pin, not at the ping. All right. So we've got the distance. Everything's great there. We pushed the shot. We're updating the scorecard. So let's go back to that. We've got our longest drive now. And so now all we need to do is create an LI element and add it to our scorecard ordered list. Okay, so let's do that. How do I create an element? Estrella.
Document dot create or var l. Sorry, document dot create element.
And then what do I put in here? The name?
The tag and everything, right?
Like this?
Yeah.
We just want to create an LI. And we probably want to write good code, so let's use let here instead of var. Okay? So that's good. We want to put the number of shots in here. Like, let's just say we want to recreate this syntax to begin with. So we want to, right? So how would I put the number of shots in this new element we just created? Any ideas? If we know that our LI looks like this is what this EL is, how do I put stuff in here?
The inner text or inner HTML.
Sure, let's try it. EL.inner text equals, what do we want to put? We want to put our shots length, right?
Yeah.
Shots.length, and then we want to have, just to recreate what we have here, plus, shots. Okay, now we need to add this element to the page. How would I do that? We know that we have a scorecard element. How would I add this element to the bottom of it?
Append.
Okay, on what?
Append. child. Oh.
Okay. So you're saying I need to run append child on the ordered list? Is that what you're saying?
Yes.
Yeah. Okay. Be more confident because you're correct. Document.get element by ID.
Even when I'm just coding by myself, I'm this unsure.
Okay. That's perfectly fine. Like, I'm going fast because I know the answer already. You know, if we tried it a bunch of different ways and it told you there was a problem, it would tell you kind of what's wrong, right? But let's just say we know this is called scorecard, so this is an element that we want to do stuff with. Whenever we think about, like, we're going to operate on an element, so as soon as you think, hey, we want to put this in scorecard, you're going to reach for this to give us a reference to that element. So just whenever you need to touch an element, you're gonna grab it somehow. Either this or one of the other methods like get elements by class name, but then you got to loop through them and stuff. Right. All right. Dot append. You'd want to try append or?
Append child.
Append child? Does anyone agree with her or disagree with her?
I agree.
Okay. Append child. Good. And we're just going to put an EL, right? So now, if I take a few shots, 5 shots, take a few shots, and I get a hole in one shot. Oh, it says 1 shots. We probably need to fix that, but that's a problem for later. It's kind of working, right? But we also have, we spent time making, like, what was our longest drive? Maybe we should put that in there too. So maybe what I would think to do is like, small, and maybe we put in plus longest drive plus small. Okay. Okay. So why are we seeing the tag here?
Because you're doing inner text, not inner HTML.
Okay. So let's just change this and see if this looks nice. Okay. Cool. It's making a small. And then the other thing is, we probably don't want all these decimals. We don't need this kind of precision to know that we're like 283 yards, 0.34 something, right? So what would we want to put here? To like make longest drive not such a crazy long number.
Just wrap it in math.floor.
Math dot what?
Floor.
Floor? Okay, so we just want to, we don't care about precision at all. We just want to put 501. Okay, I can buy it. Seems interesting. All right. I didn't mean to click that. All right, we're pretty close to getting something useful here. Like, it kind of works, right? Obviously, our numbers here are fake, right? Like, not 887 yards unless we're playing on the moon, but it's working. And if we went here and we actually turn this to a mobile app, all we'd have to do is, instead of fake chords, we'd maybe do this. So maybe what we want to do is, you know, Gregory was kind of asking earlier of like, if you're on mobile and we're doing a thing, like how do we, you know, if we're on a desktop, we want to test this out. But like, maybe instead of this being fake chords, we just make this be get chords. And then, right, we know that this code is here. So we can just do, right, like, in the future, use this, right? So fake chords, or excuse me, we should call this get chords, right? Function to let me test the game, right? Yeah, good. So we'll want to change this note, right? So we'll say get chords is going to return either real coordinates or fake ones if I'm on computer, right? We don't know how to check that yet, but what we can do is this part is working. This is our fake coordinates, so we can just leave ourselves a note that says use real chords in the future. So we don't have to go and change all the places we're using. What do we call it? Fake chords. We can just use get chords all over the place, and then only have one place to update. So I can take this out right now, right? And we can even change this, right? So get the current chords. And then the other place we use it, yeah, get chords. So now we have one good function to get us our coordinates, and we can, when we get to this, we can make it so that this will return real coordinates if we wanted to do so. And maybe what we do is we're going to have a check in here that says, if I'm on a mobile phone, assume I'm playing the golf game correctly, or maybe I'm just entering data if I'm not moving, and so then it asks you how was your distance. Maybe we don't get to put in distance. If you're just recording, as you went and golfed with your buddies on the weekend, you didn't play with the app. Maybe we still have that fallback so that if you're not on mobile, you can put in, how many shots, you can all the information, because we created it now so that it all happens on button click instead of data entry. But we might need to fall back on data entry so that the app is useful in both contexts. So let's think about that for sure. All right, so we have get chords. It's returning our fake coordinates. That's great. We need to take out these fake LIs that we were put in here. Right. So now everything works. Take a shot. Next hole. Take a shot. Next hole. Okay. Now we maybe want to have like an end game which calculates our final score, or maybe we want to do it live. Right. So another thing that kind of jumps to mind is I'm on hole 6 right now. I click take a shot. What am I currently shooting? I don't know. So maybe let's just say maybe we need like a current hole option up here that says like hole 6, and as we take shots, we update the current shot count. That's maybe interesting too. Let's try that. Okay, so this is our golf score, and maybe on here we say, strong current hole. We put in a span. Span ID equals current hole. Span. And we can default this to be 1, so that when we load the page, current hole is 1. And we can just put that right in our HTML. But we're going to replace this every time I click next hole with, it'll say hole 2, hole 3. And then we probably want to do the same thing for shot, right? So let's do that. We'll say shot 1, current shot. So this will go 1, 2, 3, 4, 5 as we click next shot. Everyone following along? Okay. So every time I click take a shot, we're going to do, it's this function, right? Process shot. So let's just say, we can just do document.get element by ID. What is this? Current shot. Dot inner HTML equals shots dot length. Right? Okay, so we got a problem here, right? Shots dot length is always behind. So let's just add a +1. Okay, and we can see I'm on shot 5. If I click hole 1, right, 5 shots. Absolutely perfect. But now this needs to go back to 1, and current hole needs to go out. So I think we probably do that in the same place. All right, so let's just copy this so we don't have to type everything. Next hole, and we'll say current hole is game.length +1, and we probably also need to current shot. We just make this back to 1. We're following along. I'm just updating this HTML. I don't even care to store this, right? We're going to let the HTML store this. We're just going to count along so that it's like a nice. Next hole. We see 8 shots. Yeah. Okay, so the problem is current hole is behind. And I don't know if you guys noticed this, but let's see, right? So we're on shot 1. I'm going to click it, take a shot. It still says 1, even though we're now on shot 2. Then we're on shot 3. Then we're on shot 4. So it's behind again. Maybe we need to even increase this. Maybe it's +2, right? +2. Because you're constantly at the shot of the next one that you haven't shot yet. Does that make sense? And then kind of the same problem here. Current hole, you're always at the 1. So okay, yep, shot 2, shot 3. Let's click next hole. 2 shots. Let's look at our game object. This maybe doesn't make sense. So I clicked the shot thing 3 times. What else? 1 click, 2 click, 3 click. So we should have 3 shots into the hole. Next hole. 3 shots. Perfect. So that makes sense. The problem in my head is that current shot says 4. Oh, okay. But we just don't take into account that, if we're on shot 3 and shot 3 goes in, like, we know that the next shot will be 4, but we're in the hole, so we're good. Okay, and then we do next hole, shot 1, shot 2, great. So maybe we just need to change the wording here, which is like you're shooting 5 instead of shot 5. Right? It's semantics at this point. Cool. And then maybe what we do is we just say like we tally up the total, right? So we know 3 shots, 1 shot, 3 shot, and we maybe say current score. So let's say here, my current score. Let's make a current score thing. We'll just say score. Maybe we put it in here, right? We've already got a nice H2. Let's just say span ID equals score. And we say 0. You start off the game with nothing. And as we we'll put this in brackets so that it looks, or maybe it needs to be appearance. Right? So we're going to have a value here that as we increment the score, or as we increment the holes, we're going to update this score value. So let's do that. Document.getElement by ID score, and then inner HTML equals. Okay, we've got shots. Before we reset the shot, we're going to do document.getElement by ID score. And we need to make sure that this is a integer, right? Parse int dot inner text. So we're going to get the current value of the score field, and then add the current value of this field, current shot. Ooh, -1, right? Because we're always ahead. Let's grab this. And we need to wrap this in parse int as well, right? Parse int. So let's just make this a little cleaner to read. So we'll say document.getElement by ID score inner HTML equals the integer of the current score value plus the integer of this score value -1. -1. So pretty simple math. We haven't had to store any new variables because we're letting our document object model be the thing. So, right? Great. And now we say our score is 3. And we say, right, score is 8. 5 plus 3. Now, I like that this shot is updating. Why we should maybe make this update as well. Does that make sense to you, everybody? And then maybe we don't even have to do this math, right? So if we don't have to do it here, we will. Let's just try. Right, so let's take this out for now. Let's just say score down there. Oh, because it's always starting from 0, maybe? Let's think about it. So we're going to go into our process shot, and we'll say score.innerHTML equals same thing. Score.innerHTML parse int score.innerHTML plus 1. Take a shot. 1, we're at shot. So our score is 1, and we're on shot 2. Score is 2, we're on shot 3. Score is 3, we're on shot 3. Let me click next hole. 3 shots, that's our score. Now, 4, 5. Oh, this is working perfectly. So that's even simpler. We don't have to worry about subtracting and addition. Everything's great, and I like that much better. It's cleaner. So let's just take out this previous thing. So the score is going to update in real time with our shots, and then as we click next hole, we're going to capture the score of the hole. And then really the last thing, like, when game's over, we probably need a function save game or end game. And really this just needs to store our game object in local storage or a database in the future. And so we just do local storage dot set item game data game. Alright, so we can make a button that at any time, we can just say a button is in, end game. In game. That in theory, we're probably going to want to make this game data thing that we're storing in local storage. We're probably going to want to make that an array as well. So game, we're probably not going to store it like this. We're probably going to have this, like when we start the game, we're going to pull this out of local storage so that we've got an array of games. And we're going to kind of do the same thing we were doing with games and shots, where we're going to say the game is done, push this game object into our game data, and then store the entirety of game data in here. But we've now built kind of like a little golf scoring mechanism that's tracking our distance, and all we need to do to make this live is when we learn how to put this on a server, all we have to do is update this one function. Where did we put it? Let's just do get chords. Right? We just have to replace this with this, and now we're walking around a golf course tracking our shots. That was pretty fun. Any questions? Anything here that you don't understand or you want to go over in more detail? The part I'm really most proud of is string.prototype degree to radian, so that I can never accidentally try to convert a string number into a radian. No questions. Esrea? Yep.
It might be a dumb question, but how come you don't have to stringify it before storing it in local storage?
Oh, you do. We would want to. We would want to do JSON.
I thought I was missing something,
and
that we didn't have to.
I was literally just showing, kind of like, hey, the next step is we're gonna have to store
the
all this
idea.
game data.
Yeah.
I was just typing out loud. Yeah, correct. Good catch. And if we run this, right, we probably also need to, clear out our page information, clear out our local variables, right? Because, we're going to have these numbers in here. We want to reset it back to 0, all that information. But now we've built a golf game that tracks our distance. And now, if we actually do store this correctly into local storage or into a database, when we learn about that next week, then we can build a second page that loops through all of our games and sees, what was our best drive we've ever made? How did we do on hole 4? All the stuff that Andrew is really excited about from an analytics standpoint. We've now, with just 3 buttons, made it so that he doesn't have to do as much data entry. The one thing of his interface that we did not replicate here would be he was tracking the number of putts. And I think we probably want to do something different in putts. We're tracking shot distance in yards. These are 475 yards. We probably want to have even more information, which is shots 1, 2, and 3 was we probably want to have a fairway button, a rough button, a sand trap button, and then a green button, so that we know what type of shot we were taking. And if we're on something when we get down under 20 yards, we probably want to switch over to feet, right? That's when, you do a 200-yard drive and a 15-foot putt. And I think that's more interesting data. We could add a couple more buttons, but it would be just more of the same of this, what we've been doing in here. We'd say, hey, this is a putt. Maybe this shot info object that we have here, right? Process shot. It says, maybe we actually need to pass the event in here so that we can say, what is the event target? If I'm on take a shot, take a putt, take a whatever, and then we also would include shot type. So we would maybe come in here and say, shot info is get chords, but then we also say shot info dot shot type equals putt, or whatever, so that as we're clicking this, right, we know, shot one. If we look at game, or shots, right? Now we've stored the type of shot that it was. If we just added a few more buttons, and maybe we attach it to which button did I click, we know this because this is going to tell us an event.target. And then we can make this even better by making it granular and saying something like, if it's a putt, we probably want the distance in feet. So instead of, right in here where we're kind of doing shot distance, we would just divide by 3. Not on this one, but on the previous one, right? So, so like in here where we're doing this shot distance, we'd probably want to have a, if shots dot length minus 1 dot shot type equals putt, right? Like, oops. Hey, what happened? We're gonna do shot in feet instead of yards. And then we probably also need to have in here in shot distance, right? This is just a number. Like game. Right. Each of these distances is a number. We probably need a, if we're not going to store this as like it's like this 134 yards, which would be like 360 72 feet, right? Like we either are going to store the number in here in a small unit, or know that we have to convert everything to math, whether it's feet or not, or we might just say like the distance is the number and we're also going to include a unit. So it'd be like 134 and then feet. I think I would probably lean on the side of like, let's normalize it so that this value is feet. And then always know that if it's not a putt or not something like a chip or a pitch, something that's close distance, then I'm going to multiply by 3 to turn it into yards on the display. I like to store the smallest unit that I can. And I do the same with money, right? Money's a great example. It's like $10.50. When you're working in databases or when you're working in code, it's almost always better to convert everything to pennies. So you'd store it in a database as 1,050 pennies. Because that's an easier and safer number to travel around. So you don't have to worry about like, oh my gosh, I divided, what's half of 1050? Right? It's 525. But if you divide it by 2, sometimes you'll get weird math errors where it'll be like 5, 2, 5, 6, 7, 8, 9. Right? I'm sure you guys have seen like fractions of pennies before. And that just causes all kinds of chaos where if you don't catch it, maybe you're building some kind of accounting software and you've got all these lines of invoice items and you end up being off by large numbers months in advance because you've been doing math on something that you divided by 2, right? Amortization is a good example of this, where you say, I bought a computer and the computer's $1,000. I'm going to expense that over 12 months. Right? So what's $1,000 divided by 12? 12, right? $83.33 repeating per month, right? Like that's bad. Okay, but 10,000 divided by 12 is 8,333 pennies, and we can just round. So it prevents a lot of that sort of thing. Cool. Now that we built Andrew's entire app for him, what are you going to do next, Andrew?
I mean, I'm gonna go and try and play with all the navigation stuff, the navigation object, Um, I probably wasn't necessarily going to track every shot distance, probably just the drive. Um, but I definitely want to add some more math in the background to use now that we've done a lot of stuff with objects, I want to do some create some functions to do math on the object so that I can get back some data, like some feedback data.
Cool. Yeah. I think your app in particular is fascinating because I know a little bit about golf and I'm obviously not very good. But I think that like some of the data that you can get from a tool like this will help you improve your game. Like even on the putting side, where you were saying I'm not maybe gonna store the distance, but if I know that if I'm 30 feet away from the pin, I almost always 2 or 3 putt, right? Then maybe my goal should be to just get within a foot of the pin where I almost always 100% it, right? So instead of trying to sink a 60 footer, I just try to improve my game so that I get up myself within like a 2 or 3 foot radius.
Yeah, I think the distance on the putting is a cool thing because that's a cool stat to track also.
Yeah.
It's statistically people don't make super long putts a lot of times, so
yeah.
Just
So
having if you made having maybe being able to show like a percentage of like a radius of percentage of like what radius you're best in, like you were saying, trying to go for the 1 putt or trying to just lag it up there and do a 2 putt.
Yep. I think the cool thing about this is that combining a few lines of JavaScript with being able to get coordinates has given you the ability to measure distances fairly accurately without too much effort. And so you could very quickly, we could put this on a server today and actually go out and start like testing this just with these 3 buttons to be like, is this a useful interface? Are we getting data out of this that is worthwhile? Is it telling us anything? Because I think the value of your app is not logging the data. I think the value of your app is the analytics that come out of the data at the end. And so anything we can do to make logging the data easier, right? Rather than you having to like sit in your golf cart and punch in all those fields, if you can replace that with just a few buttons so that it becomes an organic part of your game rather than writing something down on paper or data entry, which maybe is not as interesting. I don't know, but it's the main point.
Just the way I've.
What was that?
Oh, sorry. I was gonna say kind of the way that I've visualized it as working on the phone is to be just as far as being super user friendly. Having very few buttons, not having to like type in tiny fields, but just being able to like mash a big circular button on your phone and to start and stop or track something or pick something. Even as far as like I was going to do some research later, like what color combinations are most visible in high sunlight on the phone, just so that you can you could actually use this and track your data. Because I was talking to somebody about this the other day. All of the stats that I'm tracking on my actual app, those are, when I go play golf, I fill out my scorecard to, I play by myself a lot, so I'll write all these data things on there, and I'll just track the 18 holes, like checking yes or no if I hit the fairway or the green, and writing distances down. Mm-hmm. So it would actually be useful.
Yeah, the main purpose of all of this was to show off this. How do we get our coordinates, and then when we have coordinates, how do we calculate the distance between those two things? That's a super interesting thing. What Andrew just said was like something I've lived my entire life by, and this is a bit of like a tangent, but I hope you can take this as like super useful. Every software product that exists, the reason that it exists as software and that companies are willing to pay you to be engineers is that you're solving somebody's problem. Hopefully you're solving a problem that is valuable or that like somebody wants to pay a lot of money for. That's why we're going to get jobs doing this career. But Andrew's use case here is a perfect example of like how I've lived my life entrepreneurially, which is I have an idea for something that will make something better for me or something better for somebody that I care about, and I'm going to build a tool that does the simplest version of making that easier for them, and then I'm just going to iterate, right? I might start with something that looks exactly like this if I'm Andrew, or if this is my problem, and I would go out and I would play a couple games with this and see if it's going to create any value for me. And then hopefully, if you continue to iterate, If it's a problem for you, it's probably a problem for other people as well. And then maybe you have something that is a business, or maybe it's something that's worth buying, or you maybe put it in the App Store and people pay you $1 for it. I don't know. But as software developers, as we go into our careers, your employers, or if you work for yourself and you start a company, you're always we're using software to solve people's problems. That's the job. We are typing with our fingers and thinking with our brains and coming up with solutions that make some part of life better or more bearable. Cool. Any questions about any of this? This is all going to be checked into version control, so you guys can all play with this code. Specifically, I even put in a link to the Wikipedia page. If nothing else, remember the word haversign, or when it comes up, you should know this is how I calculate distance between two places. I've used this algorithm probably like 40 times in my life in 40 different businesses. It's very, very useful. And I never remember how to do it because I don't understand the math that well. Like, I'm not a math whiz. I just know that if I use this, the answer comes out the other end, right? You don't have to be super smart to be a programmer. You just have to be good at reading and good at playing. Alright, it's 8:02. Would we like to play with something else? Would we like to maybe make something draggable? That's kind of fun too, huh? Alright. Great. Do we need a break or anything? Or do we want to just plow ahead? Anyone need a bathroom break? Maybe we take a short break, 5-10 minutes instead of 15? Okay. It's 8:03. Let's come back at 8:12. Today. So I did upload this GPS to GitHub. So if you want to refer back to any of the functions that we've used, specifically like the navigator element in here, right? Like, how do we get our current position? How do we do stuff with it? All that code will be in here for us to play with. Okay. It's not just Andrew who may need this in the future. And then the other thing to keep in mind is the name of the algorithm is haversign. So remember that. Okay. Next, let's make something draggable. Right. I forget who asked. Maybe it was Leah a couple weeks ago. I want to drag an element. I want to be able to move it around the page. This is extremely easy. There's a couple different ways to do it, but we're going to look at the first one. Which is an interesting one, right? So let's make ourselves a new folder, and we'll call this dragging, right? And I'll try to move quickly here, just setting up everything how we need it to be, and so we'll be respectful of our time tonight.
Are you gonna share it?
I am, as soon as I forget to. What will we do without Selena keeping me honest here? Alright, cool. Everyone can see, I hope. Perfect. Alright, dragging things. And we need to script type source equals JS. Drag.js. Right? New file, drag.js. Cool. Alright, so let's assume we've got a div here. Div class equals drag. And we'll say this div has, like, hello, right? Let's give this a little bit of a style. 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 And we will just give it a border and maybe a height and a width. Let's make this a square so it's easy to kind of visualize this as a thing we're dragging around. So we'll say dot drag. We'll maybe say border 1px solid black. Maybe we'll say background color is like not quite gray, and then we'll say width. Let's just make it like 50px, height 50px. Okay. So if we look at this in our browser, open with live server, we drag it over here. We can see we've got this little box that says hello. Let's maybe make this a little tiny bit bigger. Let's make this 150 pixels, right? Cool. So we got a box. It's too big. I don't like it. 100 pixels. Right. We got a box. We want to make this draggable. Now, we were kind of playing with this when we were learning about events. We know that we've got some mouse options. What are some of those mouse options that we have available to us? I could just take some notes here. We have some mouse events. Which ones do we think we want it so that when I click this box and I hold my mouse down, I drag it, it moves to a new spot, and then when I let off my mouse, there's 3 things right there. What is the first one? We know there's click, right? That one's a single click and a release, but we need a click and hold.
There's drag.
Okay, mouse drag is one that is interesting. We can look at that for sure.
I know there's a key down. Is there a on mouse down?
Mouse down, yep, that's one. So releasing the button would be mouse up, right?
Mm-hmm.
Mouse up. We know we have a click. Right, we've played with that before. We know we have a double click. What's another one? When I'm wiggling my mouse here, what event would that be?
Mouse on or mouse move.
Yeah, mouse move. Yep, that's it. Okay, cool. So we've got a few different elements here that are interesting. So let's create ourselves document dot add event listener. All right, we want to make sure that DOM content loaded. Right, function. All right, so we need to bind some events here. So let's maybe just bind all of them and see what it gives us. Right? Let's do document dot add event listener. And we'll just say mouse move function. We need the E. We need the event. So when we move our mouse, we can do console.log mouse down, or mouse move, excuse me. Move. And let's just put an event. Right, so we're gonna log this event, and this is gonna cause a bunch of crazy stuff to happen because our mouse is moving a lot, right? So developer tools, yeah. If we save the page, why is mouse move not working? There we go. DOM content loaded. So yeah, we see we've got all these objects. We want to explore this. Let's take out this. Right, we know this is mouse move. So when I click on one of these, we've got a whole bunch of information here that is probably going to help us drag stuff around, right? The ones that kind of jump to mind, we talked about this the other day, was like, you know, our page Y, our offset X and Y, our client X and Y. We've got a couple of coordinates in here, X and Y coordinates, like on a 2D plane, that are probably going to get us pretty close to what we want. So let's start at the top, client X and Y. Okay, but let's think through our flow here, right? Let's turn off this logging so it doesn't make the page go crazy. Right. What do we need to do first, right? So we only want to drag in a few scenarios, right? What are those scenarios, right? When I click on a draggable element and hold the mouse down, move the element to a new position, and then when I release my mouse button, drop the element to where it is, right? So I click, I drag, I release, and that's the new spot of the element. We probably want the element to like follow our mouse around too, right? So when I'm dragging, I can see that it's moving. So that actually simplifies things a bit for us. Okay, so let's maybe start thinking, when I click, right, we're probably gonna wanna use not click itself, because click is the I click and release. Like we're using this for buttons and for links and stuff, it's the click and release. We just wanna do mouse down, right? So let's try that. So we'll say document dot add event listener mouse down function e event, right? And we can call it whatever we want. You know, I am notorious. I like to call these E because I know it's an event, and so I'm going to type less words. But for the sake of class, it's called event, so we know what it is. Okay. Right. We know that we only want this to happen on anything that has a class of drag. So how do we check that? If I click anywhere else in this page that doesn't have a class, right? If I do console.log event.target, clicking on the page. If I do it here, it's giving me that div, right? It's going to be event.target is the element we've clicked on, right? So how do I check to see if it has this class that we care about? So let's maybe write that down as like only work on elements of dot drag. So how do I check that?
If event.target, and then dot element dot class list dot contains. Would that work?
Dot element dot class list dot contains.
Yeah.
So the event dot target is an element already. So
Oh,
let's just do
I'm sorry.
class name dot contains, and then we
Yeah,
put in
and then in
drag.
parentheses. Yeah.
So that's a perfect way. Her way is the way that Leo just recommended is actually a very good way to do this, because this is saying, hey, if the string drag exists in this class name at all, operate. I was going to recommend that we just said class name equals drag, but then this would break, right? If we do console.log draggy drag me, right? So we're going to log if this is the truth. Yeah, you see, drag me is firing. If the class had another thing that was like cool style, right? Then it would not fire. It's not going to say drag me. But her way is better. She's using .contains, which is a string method that returns true if the string contains a string. So now, if I have drag and some other style, now it works even better. Contains. What's
Class list dot contains.
class list? Oh yeah, because it's a right. It's working, and the reason is right. And I didn't catch this when we were talking about it, right? So right, if we do document get element my class name, get elements my class name. I'm just trying to get a reference to this. Drag, right? And we say 0. Right? Var L equals. Right? So this is our element. L.class_list is an array. Well, it's a DOM token list, but it's an array that has all of the different elements in here. I was operating under class name, which is a string. So we could have done the string method to do this would be like search. We could do drag. Right, and it's going to tell us if we picked something that didn't exist, it's going to return -1. So we could have also done this way, drag. So, so this works, or we could have done this. Search. Class name does not equal -1. Right, so either way would work. This works, and this works. It's just important to note that .search operates on the string, and .contains operates on the array. Okay. Cool. So this is working, right? We'll use Leah's because that's cool. All right. All right. So we're in here. We've moused down. Now we want to move it, right? So if mouse down, so like, if we are mouse down, and we move the mouse, move the element, right? So we are at this point, right? So we would need another event listener for mouse move, and we want in mouse move to do something if a value in here is true, right? So maybe what we do is just a simple thing is we say let dragging equals false, and in here we say dragging equals true, right? So while we're on mouse down and we're in an element that contains drag, we say, hey, we're dragging right now, so that when we make a document.add event listener mouse move function event, if we are dragging, let's move our element. Okay, that's cool. And then we definitely need a document dot add event listener mouse up event, and we can say here if we are dragging, stop. So we say dragging equals false. Right? It's really truly this simple. Right? We're saying if we're on mouse down and we're dragging an element, drag it. Say yes, and then we move. Right? This is where all the magic is going to happen. We're going to have to do something in here with some of the properties of this event object and actually move this element around the page. So let's take a look at client Y, which looked interesting, right? So let's just do console.log event.client X and then event.client Y. All right, and let's only do it if dragging. Right, only do it if we're dragging. Okay, so if we're in here moving around, everything's fine. Let's turn off this so that it doesn't log for us. We're moving around, everything's great. When I do this, now I'm getting some coordinates, and you can see that it goes, up and down as we move around the page, right? We kind of took a look at that the other day. So I think that's really interesting. Let's maybe put that information on the page somewhere. So let's come in here, and let's just say H. Let's just do, we'll call it code. Right, so it looks nerdy. And we'll say span ID equals mouse. Or let's just say client X. Say 0, whatever. Span. Let's actually make this a dash so that we know if it's a dash, it's not doing anything. And then we'll say span ID equals client Y dash span. Okay? So let's put this in here rather than log it to the console. Let's say document. Let's give ourselves a function real quick, so I don't have to type this over and over. Get L ID. We'll say return document get element ID L ID. Right? Good. So let's just do get L client X dot inner HTML equals event dot client X, and we'll do the same thing for client Y. Client Y. Client Y. Okay, cool. So this is probably going to be really important to us, right? So if I'm dragging, yep, I can see that my values are going up. All right. But we need to move this around the page, right? So how are we going to do this? All right, we probably need to store this somewhere, right? We need to store it, like, as soon as I start dragging, we probably need to store our current position, right? Because we're going to start from here, 4471, and we're going to drag to here. There's a difference in, we're going to want to move this element, that exact ratio, right? Because if we just move our element to wherever we end up at the end, right? Here, let's maybe do that as our first step. So one thing to note is that when we're moving elements around, they need to have position absolute. Okay, and there's a reason for that, and we'll talk about it here in a second. But let's just say on mouse up, right? We've got our client Y, right? Let's just say get L. What is the name of our? Oh, we don't have an ID for this. Okay, let's. We're gonna create an element. Let dragging L equals nothing. We'll just say it's null. All right. So as soon as we click on an element that is draggable, we're gonna store a reference to this. So let's say dragging L equals event.target. Okay. So when we click on this, we want to say, hey, this element is the one we're dragging. Okay. Then we move. Then when we lift up, we're gonna say dragging L dot style dot top equals event dot client X. So wherever our mouse ends, we can do dragging L dot style dot left equals event dot client Y. All right, I think that is probably correct. What? Oh, because I was clicking on a page. So let's just give ourselves a safety check. This error says cannot read property style of undefined because I clicked this button. I clicked this page to focus on it. So the mouse up is firing, but we never assigned a dragging L. So let's just check if dragging L. So if we have one, we will drag it. Okay, so now I can click on this page, everything's great. If I drag this, you can see the numbers changing, and if I let go, nothing is happening. Why is nothing happening? Let's do we save this position absolute. Yep. Let's maybe even just put in a top 0, left 0. So now, yeah. But when we move our mouse up, nothing's happening. So let's debug this in real time. So if dragging L, let's do console.log dropping the element. Right? Let's maybe we want to push this down a bit. Let's say top 25 px left 25. Oh, I see what the problem is. So the problem is this. I put in event client x, which is a number, but this needs to be plus px. We have to give it a unit because it's CSS, right? Px. So now, in theory, yeah, okay. So it's kind of moving, but in a way that is not quite right. Right? Like when we're dragging, something is wrong here. Let's see if we can narrow this down. Okay, so we've got our coordinates reversed, I think. Right? Yeah, it's moving down when we want it to be moving up. So let's just switch these around. So this needs to be client y, and this needs to be client x. So the x coordinate is our left and right axis, and our top coordinate is up and down, right, like this direction. And so I had them reversed. So yeah, it's kind of working, right? But you'll notice that it moves to where the mouse is, which is not quite what we want, right? The top and left of this element is there. So we need to do some math that says wherever I click in the first place, we want to subtract that from where we move to, okay? And we also want to like move this around as we're moving it. So let's just see if we can copy this information. If dragging, let's just see what this does to begin with, right? Like event, or let's say dragging L dot style dot top. Let's do left equals event dot client x plus px. Dragging L dot style dot top equals event dot client y plus px. Okay, so okay, cool. So it is working, but you'll notice that we are wherever we click on this thing, it's immediately moving the top and left to that. So we're gonna have to figure out the offset between wherever we click and wherever we move to. Okay, so let's put this as a note. To do, figure out the offset of where my mouse is versus where we click in the element. Right? Because we really want to have like, wherever my mouse is, I don't want to make this the left. I want to make this wherever my mouse is of the element. So let's see if we can figure this out. All right. So when we start clicking, when we make our click, we need to store our current position, and then while we're dragging, we want the top and the left as we store this to be subtracted from that previous position, right? So let's see if we can do that real quick. So let's just give ourselves 2 extra variables. We'll say let mouse x equals whatever, right? Let mouse y equals whatever. We can call this whatever we want. So when we go mouse click, we need to store these events. So we'll say mouse x equals event.client x, mouse y equals event.client y. All right. So we're storing that to the page. Okay, but then when we're dragging, we want to do some math with that value we stored to like subtract it from the element itself, its current top left. How would I do this in math? Let's see. Let's see here. So we've got our mouse x and y. Are there other elements we can hear? Let's look at event.target. Let's maybe look at this console.log event. Let's log this and see what we get in here. If there's anything that pops out as useful. Alright, alright, click, drag. We got a mouse event. We expect that. Let's go look at target. The target itself probably has a value that we need. Interesting. Offset top and offset left. So let's, right, if I'm here, let's just see if maybe subtracting this from our previous mouse position will help us here. So let's think about this mathematically. So as we're moving this element, we clicked on it somewhere, and as we move it, we want to have this value 88,102 be subtracted from what we move it to. So, thinking of like here. So let's use left as an example. It's probably something like dot left equals like the element offset left minus client X. Let's see if that gets us close. Let's just try it. So dragging L dot offset left minus client X. Dragging L dot offset top minus. Oh, okay. That did something wild. I don't know what it did. Let's see. Ooh. Where did it go? What is it doing? All right, let's log some of this out and see what we're getting here. Console.log dragging L dot offset left. Let's just see what this gives us. 20. Wow, it's giving us a bunch of stuff. 25, negative 27, negative 79. So we probably need to store. Right, so the offset left. Offset right. Let's see. Offset. And it just gets bigger and bigger and bigger. Why would it do that? 26,000. Holy moly. Oh, it's moving somewhere. So, alright. It's probably because we're putting this in here. Let's just take this out for a second. Event.client X. Let's take this out. Whatever we're doing is wild. Okay, now we're getting real values again. Alright, so we're at 552 right now. If I click in here and I drag a little bit over to the left, it goes from 552 to 588. Even though I just moved I moved a few inches. Alright, so where I started clicking was inside, was like by 588. Maybe what we need to do is we need to on our mouse move regardless, we need to update our current mouse coordinates so that we can see this math happening in real time. So we'll make right. So we have our mouse coordinates. We click here at 58. Right. So now we're going to make the top 64. So we need to subtract 64 from our difference. Sheesh. Alright, let me think about this. Anyone have any ideas or thoughts? How would you go about solving this mathematically, do you think? Right, if I'm at 24, this all works. But if I wanted to grab it in here, I need to subtract 96 from the top. Maybe we had it backwards. Let's try doing it the other way. Let's do client X minus dragging L offset left. Okay, interesting. That's kind of close. It's doing some weird flickering thing, but it was a little bit moving around the page. All right. Cool. I think there's probably a better way to do this. Go ahead.
It's just an idea. Is there any default functionality that, like, if we did prevent default, would it maybe there's some sort of default functionality that's causing it to automatically do that?
Let's check. I don't think so, but it's always a good idea. Yeah, so we're still doing some weird glitching thing. So I think we have a math problem in here somewhere. So whatever reason, like as we're right, so we probably have some event value in here that lets us know where we've clicked, and we have to subtract it from the element, because it's kind of working, but it's going wild. I'm sure you guys can see this. Hopefully you can see how it's flickering. So we're kind of close. I mean, what we were doing before was right? Like event.clientX and event.clientY was moving this around the page, but we want it to be like really pristine. Event.clientY. So I mean, we can make a whole bunch of other variables, right? We probably need like a like a let store X, let store Y. Right? We probably need to do some kind of wild math in here. Maybe something like, like so when we're dragging, we have to take. Right, so right, we got our mouse X, mouse Y. That part's all working correctly, but then we have to store the previous location so that we constantly are like, right. So instead of doing this, we do mouse X and mouse Y. Mouse Y. But instead of doing this, we would maybe come up here and say, let's take out this event. All right, so we'll say like mouse X equals, what did I call it? Store X, store Y. Store X minus event client X. Mouse Y equals store Y minus event client Y. Okay, but then we have to say store X equals event client X, and then store Y equals event client Y. Okay, and then we probably need to we have to set these in the first place, like when we start the drag. So here, right, where we have mouse X and mouse Y, we probably need to have it so that we store the original click place in the first place. So what we're doing here is we're saying, hey, wherever we started clicking, 60, 77, we're going to put in store X and store Y, 60 and 77. And as we're dragging, we're going to say store X minus the current version. Right, so let's see if this works. I think it works mathematically. Okay, close. Except we're a little bit backwards, it looks like. Maybe we'll, let's take this out. And oh, what happened? Where did all my stuff go? Must have hit some cool Windows key code. Where's my, there, right, cool. I can't see everybody. Alright, so that's doing something interesting. Let's zero all these out to begin with. Let X equal 0. Let Y equal 0. 0. So let's start assuming everything's correct. When we start our mouse down, we're going to grab the current value, put it in store X and Y. Okay, so maybe we have some math here. Let's see. Let me think here. So we got our mouse X and our mouse Y is store X, store Y, client X, client Y. And then we're saying the top. Let's move this so we keep in the same order. Right place. Actually, the top is so the left is mouse X. Okay, let's try this. I think this is where we would use. Let's try this. Dragging L offset left minus mouse X, and then we'll do the same thing here. Dragging L offset top minus mouse Y. So as we're moving around the page, oh, there we go, crystal clear, nice and smooth. We did it. Okay. Let's understand how we did this. Okay, so this offset left and offset top is the offset of this. What's the formal definition of this? W3 schools. Let's just search Google. Offset left returns the number of pixels that the upper left corner of the current element is offset to the left of the parent. Right. So where it's at on the page, this offset left is going to be like from 0, 0, right? So if we looked at this right now, what do we call this document? Right. So EL dot offset left is 486, right? So if we load this right now, right? It's we're on 2425, and if I run that same code, offset left, it's telling us we're at 25. So if I move down to here where I'm at, let's say 100, right? Right now it says 25. If I move this over just a tiny little bit, you can see that it's 30. Oh, but it's still doing the weird thing where it's dropping it in place at top. Okay, so we're close, definitely close. Let's take this out. Alright, so if we have our top and our left, store it, get the elements. Alright, it's at 8:48 right now. I don't know if we can debug this properly before the end of the day, but it's maybe like a good thing. We can think about this over the weekend. I'll check in this code. You guys can think about it too, and we can fiddle with some of these math values in here to see if we can figure out how to correctly have this drag around the page. And then as we jump into background next week, we can start next week on Monday with this, hopefully get it sorted out correctly, and then really start working on some cool backend stuff so we can start building interactive apps. Is there any questions? I don't want to spend all night trying to debug thinking of math on the fly. And we're just trying to show you here, like, this is the way you can write this in JavaScript. But in reality, you're almost always going to pull some library off the shelf that's like implements dragging, where they're going to have a whole bunch of features that's like draggable, and then it'll have you might have a class that says droppable, so you can have, a place where it can be dropped into. We can write all of this ourselves, but this might end up being, as you can kind of see, this is like lines of weirdness, where we have to worry about like what is the position of the element and in relation to our mouse. And while I'm confident that we can solve this if we spent probably 10-15 more minutes, it's just not that useful watching me sit here and try to fiddle with math. But you can kind of see the flow, right? We needed a mouse click, we're going to say we're dragging, mouse move, we actually drag, and then mouse up, we drop it. I'll check this in and you guys can look at it over the weekend as well. Any questions? It's been a good week. Next week we really start diving into some back-end stuff for the first time. So we're going to start learning Node on the server, JavaScript on the server, which is fun, because then it lets us do a lot of really cool things. Any questions? Anything you want to talk about?
So
Oh,
if I,
sorry.
sorry, go ahead, Leah.
So in my card app, I have my cards as relative, like for the animations to work.
Mhm.
Would I have to change that to absolute
If
to
you
get
wanted
job?
to move it around this way, yeah. Relative would work, I think. Let's just try this. But it will. It's like relative to its parent. Yeah, so it breaks all of our. We'd have to use something else besides offset let. Like the easiest way is to say we're position absolute means that we're controlling where this is on the page by the top and left properties, right? So if I say this is top 100, it's moving it down. If I say left, 500, right, in the middle of the page. So that's all we're doing with JavaScript here is we're saying let's move this in relation to where our mouse is. So relative is relative to the other elements on the page, so things can break if you wanted to use this kind of dragging. Oh, you know what? This right here. This was the thing that was causing our read bug. When we dropped it, we were setting the client X and client Y down here. So now it works perfectly. Whoops. It's what writing code on the fly like this, where we're testing something simple. It caught us. But we'll check this in and use it. It's still probably useful to play with, right? Knowing that you need to do some subtractions here to subtract where your mouse currently is from where you started in the first place. Cool. What else?
So next week you said we're gonna start doing backend stuff. Is it? It's gonna be Node.js.
Mm-hmm.
That's what we're gonna be doing.
Yep. And all Node is I don't know who created it, but they took the JavaScript engine that powers Chrome, that is inside of the Chrome browser. They took the JavaScript engine itself and said, let's just run this on a server and let it do scripts. So now there's a very robust ecosystem of people that are using Node.js. We've got like a package system, so you can pull in modules, and like if you wanted to connect to your database, you would say use MySQL or import MySQL, and now you have a library of MySQL at your fingertips and can store stuff in a database. So it's still JavaScript. You're still going to write .js files, but now we can write JS files and put it on our, we would like run it inside of git bash, and in here when we're running our code, if we wanted to make a server, for example, we could use Express, which is a server engine for Node, and then we can define, hey, when someone clicks on this link, our server will respond with an HTML page, instead of using the live server plugin that we're getting through our browser or through our editor.
Is it pretty much semantically similar to JavaScript and just different in implementation, or I mean, I'm sure there's a few other like keywords and stuff like that we'll learn, but for the most part, is the syntax pretty much the same?
100% the same as JavaScript. It's JavaScript, but
okay,
on the server. So the only thing that we'll have to start learning is when we start using Node modules to make things happen, right? Like we're not going to write our own web server. There's already a web server called Express that does that. So we'll just pull in that module, and then Express has its own API. They'll be like app.listen, and then that listens on a port, 5500 if we want. And when a request comes in, we'll just have to learn JavaScript to do things with modules. And each one of these modules, just to give you an example, like npm, let's go here, and I'll use Express because we've been talking about Express. Right, we're going to write JavaScript that looks like this. Express equals require Express, which brings in the module, and then our app is calling that function, which says, hey, generate a, Express is saying, hey, in the word app, return something here, and then app.get, which is / is going to give us a request and a response, and we're going to say response.send to hello world. then we say app.listen on port 3000. This creates a little mini web server. And so we can write any JavaScript we want inside this thing so that every page will show up with hello world instead of, so we could say, if there's a file that exists in this folder, send that file. Or if there's, if we do app.post and we send form information, store the information and send back a response. So it's still JavaScript. We just have to learn, we'll have to learn how to come in here and, learn how to use it. Right? Each module is going to be, a module is just, how we've been developing code in a bunch of different ways. Sometimes we're writing classes, sometimes we're writing a bunch of functions. Every module is just built by somebody, and so how they choose to provide that functionality to us is sometimes a class, sometimes it's an object, sometimes it's a bunch of functions, and we'll just have to learn how to use it. Documentation right here. That's what I was looking for. So like, is jQuery part of the curriculum that we're going to be learning also? Or it's not a formally
kind of
part
outside?
of it, but
Okay.
you're more than welcome. jQuery is an easy framework for doing JavaScript on the client side. jQuery provides a lot of niceties. Like instead of here, just an example, we've spent a lot of time this week learning about like making AJAX requests. So the native way to do this is we would say xhr equals new XML HTTP request, right? And then we say xhr.onLoad this function, and we say like do something here, and then we say xhr.open, and we say get index.html or whatever resource we have, and then we xhr.send. jQuery just provides a nice function that would let us say new AJAX or AJAX.send, and then URL, and then the function to run. Right, so that's what happens when it's done. Or I forget the actual syntax, but it's just giving us a series of functions that make this a little bit nicer. The reason we don't learn it, and the reason we don't spend a lot of time on it, is that you might chances are, as your web developers, you guys are going to use jQuery on almost every project. It's in use in a lot of places. Instead of saying document.getElementById, you're going to get used to just saying $, and then a CSS thing. That's the jQuery that jQuery made. It's way easier than typing document.getElementById all the time. But the problem is, so $.ajax. This is what I was trying to think of, right? The problem is, this is learning just one way to do it, and it's not teaching you what's actually happening behind the scenes, right? If we go and look at jQuery's actual source code, right, uncompressed, right, and we go look at Ajax, right, when they're writing this code, those are all the settings, right? There's thousands of lines of code in here to like give all this functionality to us, but you're learning just the Ajax way. And if you go to a job where you learn React, now you're going to have to learn a different framework where it's safer and easier to learn, like, this is what's happening behind the scenes. And then when you go learn a new library, you're going to use Ajax, or you're going to use some kind of method to communicate with the server. You just go learn that framework's way to do it. Yeah, here's that function, right? So all it's doing is, it's creating a whole bunch of variables. It's creating some callbacks, like, so whenever you pass the functions in, it's doing, like, this is doing a bunch of crazy stuff. But then it still goes through here and let's see where they actually make it. XML. Yeah, so it's actually trying to return that XML HTTP request object so that it can use it the same way we are. But it's just doing a bunch of other crazy stuff to let you have all these options, and you can say this is content form data, or this is an image, or this is whatever. Right? There's just a bunch of stuff in here that is, this is like 30,000 lines of code at this point. That's a lot. But it's all code you could write and understand yourself. jQuery used to be small and lightweight way back in the day. I'm really happy with this dragging. This is nice. Cool. It's 9:01. Anybody have anything else? We can sit and chat. I got nowhere to be. Or we can you can go and call it a day.